Great honor and privilege that I welcome you all to GeoRisk 2025, a conference dedicated to addressing some of the most pressing natural hazards of our time, like GLOFs, earthquakes, and landslides. As Vice Principal of Hansraj College, University of Delhi, and a proud strategic partner in this initiative, I extend my heartfelt gratitude to ResQore, the Center for Disaster Preparedness, Recovery and Research, and other collaborating institutions for bringing this crucial discussion to the forefront. The challenges posed by climate change and geological uncertainties are becoming severe day by day, especially in the Himalayan and other vulnerable regions. The increasing frequency of GLOFs, seismic activities, and landslides underscores the urgent need for scientific innovation, policy reforms, and community preparedness. Through this conference, we aim to exchange knowledge, strengthen risk mitigation frameworks, and build resilient communities that can withstand these disasters. As we navigate these challenges, technology and interdisciplinary collaboration emerge as our strongest allies. Advancements in AI-driven predictive modeling, satellite-based hazard mapping, and real-time early warning systems are revolutionizing the way we anticipate and respond to disasters. However, technology alone is not going to be enough. We need cohesive strategies that integrate scientific expertise with grassroots-level community participation to create comprehensive disaster risk reduction frameworks. Hansraj College, University of Delhi has always been committed to academic excellence, research-driven solutions, and social responsibility. By bringing together leading scientists, policymakers, disaster management professionals, and community stakeholders, we hope to foster collaboration, initiate meaningful discussions, and develop actionable strategies that will shape a safer and more sustainable future. I encourage all of you to engage in insightful deliberations, share your expertise, and work collectively towards innovative solutions. Together, we can transform risk into resilience, uncertainty into preparedness, and challenges into opportunities. With these words, once again, I extend my warmest welcome to each one of you. Let's make GeoRisk 2025 a milestone in disaster risk reduction and a beacon of hope for future generations. Thank you.
Thank you so much, Vijayarani ma'am, for such a warm welcome. As a special guest, now I would like to welcome Dr. Debulina Kundu, the Director of National Institute of Urban Affairs, with over 25 years of experience in development studies. She holds a PhD from Jawaharlal Nehru University and consulted for organizations like ADB, UNDP, and UNESCO on organization, mitigation, and governance issues. Dr. Kundu also holds the HUD-CO chair at INUA and serves as the editor of the journal Environment and Urbanization Asia. Welcome, ma'am.
Namaskar. A very good morning to the delegates on and off the dais. Professor Vijayarani, Vice Principal, Hansraj College. Madam, namaskar. Dr. O.P. Mishra, Director, National Center for Seismology and Advisor and Head of Seismology and Geosciences, Ministry of Earth Sciences. Sri Vivek Srivastavaji, Director General of Fire Services, Civil Defense and Home Guards. The organizers, I think it's a matter of honor to be here today in this gathering. The conference, which is being co-hosted by ResQore Technologies Private Limited and Hansraj College, University of Delhi, to discuss innovative solutions for urban and regional risk management to some of the most pressing challenges that our country is facing today: Glacial Lake Outburst Floods, Landslides, and earthquakes. I think we needed to be more proactive in bringing more stakeholders. I think many of the seats are vacant, maybe because it's a weekend, but the engagement of stakeholders, the students, because students today, ma'am, are going to take important seats of power and engagement in days to come. So also sensitizing them with regard to the climate hazards, risk, and the mitigation and adaptation strategies, I think it's very important. Nonetheless, we are aware that as urban centers grow, the risk and cost of impact of the extreme events have also exponentially risen. It is essential not only we need the demands of urbanization, but also that the urbanization in the days ahead happens in a sustainable and inclusive manner. For those who do not work directly in the urban domain, I would just like to give you a very brief picture of how urban we are. We are more than 500 million people living in urban areas, which is slightly above 1/3. 1/3 is rural, and 1/3 of the country is transitional. I think where most of the problems lie. So our ministry thinks it's with the rural development, rural thinks it's with the urban development, finally it is with, I won't say no, but the onus is scattered. So I think this is one area where we need to work. Again, we have 10,000 odd urban centers across the country, 5,000 statutory towns. Because urban development is a state subject, the state governments notify urban settlements over the years. In addition to that, the census also notifies urban centers as census towns. Those settlements which were rural but which have assumed urban characteristics like population density, and 75% of the population, male population, main workers in non-farm. So if we take these two definitions together, we are more than 10,000 settlements currently urban. So I think the numbers are huge, and so are the challenges. Again, this urbanization pattern, and the process of urbanization is inevitable. We are not going back to the rural environment anymore. So by and by, I think, and we are turning, transforming into urban. The way of life, the way we are, the way we work, the gig economy. I think the entire set, the paradigm shift has happened, and we are in the process of urbanization, which has its own set of challenges, specifically during a hazard or a disaster event. And climate change is making these disasters more frequent and intense, and the rising global temperatures are again accelerating the glacial melt, increasing the risk of GLOFs in the Himalayan region, and warmer temperatures. I think we all know this has altered the rainfall patterns, intensified landslides, and also the flash floods. The Climate Risk Index report of 2025 does show that India was the most vulnerable country affected by recurring extreme events, with a reported loss of 80,000 lives and nearly $180 billion in 400 extreme events in the last 30 years. In fact, the year 2024 marked the warmest year on record, and the first year to cross the 1.5 degree from the pre-industrial levels. Again, the Indian Himalayan region, often referred to as the third pole, faces increased risk of GLOFs, a phenomenon aggravated by climate change and glacial retreat. A study conducted by NRC, ISRO, in 2024 reports significant expansion in 676 glacial lakes between 1984 and 23 across Indus, Ganges and Brahmaputra river basins, highlighting again the growing risk of glacial lake outburst floods in the Himalayan regions. Notably, 89% of the lakes have expanded more than twice in their original areas. 10 lakes have grown by 1.5 to 2 times, and 65 lakes have again increased by more than 1.5 times. Again, in the country, around 60% of the country's land is affected by damaging earthquakes and is designated as zones 3, 4, and 5. The continuous movement of the tectonic plates, the Indian plates, especially towards the Eurasian plate, is the main cause of earthquakes along the Himalayan region, making the region more vulnerable to earthquakes of high magnitude. Again, India is one of the top 4 countries with highest landslide risk, where the estimated loss of life per 1,000 square kilometer per year is greater than 1. Most of the landslides in the country occur in the monsoon months between June and September, and globally again India contributes to 16% of rainfall triggered landslide events. In the last decade, natural disasters in India have resulted in economic losses estimated between $100 billion to $150 billion. So I think given all this, it is very important that we plan our infrastructure, the urban infrastructure especially, in a manner that it has disaster-specific resilience inbuilt. Impermeable surfaces and inadequate drainage systems does heighten the flood risk in urban areas, leading to floods. And informal settlements and the poor are especially vulnerable, resulting in property damage, displacement, and loss of livelihoods. A recent study does bring out that 1.5 degree to 2 degree temperature increase will again truncate nearly 8 to 13% of the global GDP by 2100, by the end of this century. Now, the main question that all these challenges bring to our table is that how do we mitigate this risk, and what is it that we need to do as an immediate call to action? I think it's very important to acknowledge that hazard and risk assessment is essential. We need to use advanced technology and AI models. Community awareness at the local level, at the regional level, and at the national level is very important, along with capacity building of officials, elected representatives, and citizens at large, and reviving the traditional wisdom. Our Honorable Prime Minister did launch the LIFE mission, where we are trying to sensitize each and every citizen to look at circularity as a way of life. And in this regard, NIUA is also working towards building disaster resilience. We have this Climate Smart Cities Assessment Framework, which looks at around 250 large cities, including the smart cities. How do we look at data? For the first time, we have put together collected data from these cities, and which happens annually. It's there on the website. So if one really wants to understand what is the climate preparedness of different cities, this is one set of data which is there in the public domain. Again, we are working very closely with our ministry to develop a comprehensive disaster management plan, which incorporates disaster and climate resilience in policies, missions, and guidelines of our ministry. And we are also assisting not only our ministry, but also 22 line agencies in preparing their respective disaster management plans. We are also working, we have developed a card game to train city officials on disaster resilience and climate action planning in a structured and engaging manner. We have prepared climate action plans in 4 cities across Leh, Junagadh, Jamnagar, and Pune. And I think the lay plan is very important as it addresses GLOFs, earthquakes and landslides, offering policy, governance and project-based solutions to enhance resilience in the fragile Himalayan ecosystem. Again, we are working very closely with the Jal Shakti mission, the Namami Gange team there in preparing urban management or URMP's urban river management plans across 60 cities. And we are also trying to increase the canvas, and through the cities program, which is again being funded by AFD, KFW and the European Union along with the Government of India, we are working currently in 18 cities which will be later on acting as lighthouse cities, where we are trying to mainstream circularity and develop again climate observatories in those states and cities. So I believe disasters, just like urbanization, is inevitable, and the impacts can be mitigated through science-based planning, policy integration and community engagement. We need coherent disaster risk reduction strategies, urban resilience and integration of geospatial technology in mitigating risk. Women, particularly the marginalized communities, are often disproportionately impacted by climate-related challenges. In this regard, I feel that whenever we are trying to implement or strategize action plans, we look at the rural-urban binary. I think that binary needs to be blurred, and we need, while I think most of us are aware that all our towns and cities do not have master plans or regional plans for greater regions. So I think the need of the hour is to prepare GIS-based master plans, not only for the select cities, but pan-India. And for the small towns, we could have regional plans, and again, climate action plans. We have prepared 4. Maybe other institutions who are working in this space have prepared not more than a dozen. So this sporadic interventions is not the need of the day. I think we need to have a comprehensive planning, sensitization of officials, citizens at large, and also, as I mentioned earlier, the transitional areas which are growing very fast. Those areas need to have specific climate action plans, and again, just having climate action plans is not enough. I think we need to act on those, because we do have only one planet, and the earth needs to be there for the generations to come. So I think that sensitization of the citizens at large, the stakeholders, the government agencies, researchers, policymakers and urban planners is important, and we all need to collaborate to build a disaster-free, resilient India. And I would like to again reiterate that the National Institute of Urban Affairs with the Ministry of Housing and Urban Affairs is working in this space, and we would like to work with all the stakeholders to bring about the best which we can in a time-bound manner. Thank you for your patient hearing.
Thank you so much, ma'am, for your enlightening words. Moving forward, Dr. O.P. Mishra serves as the Director of National Center for Seismology and as an advisor and head of Seismology and Geosciences at the Ministry of Earth Sciences, Government of India. He is distinguished geophysicist and seismologist with expertise in disaster management, 3D seismic topography, and crystal mantle dynamics. Dr. Mishra has authored over 150 research publications and is a fellow of the National Academy of Sciences, India. He has received several awards, including the National Mineral Award in 2008 for disaster risk management in applied geosciences. I welcome you, sir, to deliver a keynote address.
Presentation will be just now or after that?
So if you want, it's up to you.
Okay, so you can open the presentation, you can load it. It is there.
Yeah.
So, very good morning. Professor Vijay Rani, Vice Principal, Hansraj College, that plays a strategic role in this organizing the wonderful conference on a very apt topic, that GeoRisk covering GLOF, landslides and earthquakes. Dr. Debolina Kundu, Director, National Institute of Urban Affairs and co-organizer of this conference. We have just heard it was really wonderful talk she has given, a very good glimpse that what is going on and what we have to do. Sri Vivek Srivastavaji, Director General of Fire Services, Civil Defense and the Home Guards, needs no introduction because the topic says what he is holding is the paramount for the post-disaster risk management strategy and how they can mitigate the losses of the lives and property by their action. So thank you very much, sir, for here. And we have Sri Rakesh Jha, Chief Executive Officer, ResQore and Executive Director, CDPRR. My all dear colleagues, friends, participants, especially Professor Sandeep Singh, Professor IIT Roorkee, Professor Joshi from JNU, Professor Satya Prakash from NIDM, and my good friend Dr. Anirudh Roy, are the Chief Technology Officers at the International Institute, that is covering a lot of things in geosciences and disaster risk mitigation. It is indeed an honor and privilege to share the views on the GeoRisk and the topic taken as a combined of the GLOF, the Glacial Lake Outburst Flood, the landslides and the earthquake. And earthquake at the end, which is the triggering factor of the GLOF as well as landslides. You might be remember that in Chorabari Lake when burst in 2013, we are exploring so many regions, but in the team constituted by the Department of Science and Technology, I was one of the members from Geological Survey of India in that time, and we found that the micro earthquakes that broken the moraine of the Chorabari Lake, and that was actually the triggering culprit that led to the massive havocs in that time. So you can imagine that I am going to speak on this, how the earthquake causes the lot of the disasters, and if you diagnose the cause, basic cause that which is causing the disasters, then you can have a remedial and mitigation measures. So it is not only the GeoRisk, but it is also the GeoRisk and the hydrometeorological risk, because it was very related to each other. You might be seeing the recent research published that there is a monsoon-induced earthquake. You might have seen that there is a climate change-induced earthquake called a cryospheric earthquake, that is called a cryoseismogenesis. Means melting of the ice is lessening the burden of on the crust, and crust is just like a squeeze up, like a spring in the dot pen, and now it is the bursting up, so micro earthquake taking place. Accumulation of too much ice also causing the load, and then there is a micro seismicity taking place, that in the polar region and the Himalaya. So modulation of seismicity is also a proxy of the climate change, along with the precipitation, sea level rise, temperatures and all changes. And too much rain is going to be a flood, and a scanty rain is going to the drought. All these things are related to each other in the earth system science. So the topic is chosen is very apt at the right time, where we are speaking on these things. If a global perspective, the India has witnessed so many hazards, not only these geo hazards, also the hydrometeorological hazards. We have seen the massive earthquake, even it was away from Himalayan, that is the 1993 Latur earthquake, when several people died. And that explained that in order to occurrences of the earthquake, there is no need of any plate tectonism. There is no volcanism, there is no collisional tectonics, there is no subduction tectonics in the plate interior of India. Even it witnessed the massive earthquakes, means disastrous earthquakes, of the shallow earthquakes in the mid crust, like in Bhuj in 2001, 1993 Latur earthquake. They caused thousands of the people. So it says that earthquake can hit anywhere at any point of time. And when earthquake occurred, in the hilly area, when the rocks is subjected to too much weathering or too much is equal to chemical factors or any extraneous and anthropogenic activities, just a shaking can lead to the massive landslides in the hilly belts. And you have seen that this is earthquake-induced landslides. We are thinking that now only the precipitations and the rainfall is causing the landslide. That is not the fact. If there is the precipitation and there is no cracks, there is no fractures in the rock masses, the landslide cannot be occurred through the precipitation. That cracks is being subjected to generation of the seismic energy due to a microseismicity which we are not feeling. But it was experienced by the massive chunk of the rock masses in the Himalaya or in the hilly terrains. And then rocks is subjected to too much fractures and the cracks. Then they allow the percolations of the rainfalls or the precipitations. And this is the hastening the slippage of the rock masses by reducing the cohesive forces of the one unit of the rock by the others. So it was the main cause is the energy generations in any environment, whether it is anthropogenic or it is natural, right? So in the case of the natural hazards, it is very difficult to stop. It is very difficult to predict precisely. Just like in the cyclone and in the whatever in the monsoon, the prediction is able to do because they have lot of the scope of the observation system in the ground as well in satellite. But these geoscientific or geo-related hazards cannot be predicted cannot be forecasted so precisely because of the intricate process involved into it. That's why the entire world is pouring $1 billion to understand the geoscientific problems, geoscientific processes occurring that leading to the hazards. So come to this, I remember that in the Hugo frame of reference, 2005 to 2015, it was to sensitize the entire country of the world. And India was also the signatory of the 15 years in the Hugo frame of reference, and all governments of all states of the United Nations member, they have been forced to keep the money for disaster mitigation, called a disaster risk mitigation fund. And almost all countries started to keep in their budget. And there is a sensitization of the capacity building program. India was leading that, NIDM is here, that played a lot of the role in capacity building program, and NDM sensitized that. And there was the regional center called SARC. I had opportunity to interact with each and every unit of the agencies of the country to work cohesions, because disaster involved is so much havoc, it cannot be handled by one discipline, cannot be handled by one agency. It is a very combined effort, need to be in collaborations, cooperations and cohesions, that how to do that. So this is the actually Hugo frame of reference that given huge amount of money for the disaster risk reduction. After that, post Hugo frame of reference, called after the 2015, it is called a Sendai frame of reference for disasters. Now it is the binding on each and every country that you cannot stop the natural hazard, you cannot predict so precisely, then you have to develop a modality or mechanism in such a way that you can reduce the loss of life and property as minimal as possible. And here is, this workshop can give you a lot of the deliverance that what measures you can take. In such a climatic change scenario, I told you that. The area when there was no rainfall, now there is snowing, right? So climate change is modulating almost all effects. But we are only blaming the anthropogenic carbons and all in climate change. Geoscientists don't believe this. Here the Professor Sandeep Singh is here. In each and every geological age, there is a climate change. Anirudh is also a geologist. My friends, Satya Prakash Sinal. Each and every geological age, there is a climate change. Might we were reading that in 65 million years ago, there was the dinosaurs that disappeared in deciduous climate. So the climate change is totally dictated by also the internal natural processes. And you know that in geography we read that there is a diurnal motion of the earth, there is a secular motion of the earth. Diurnal motion of the earth controls the day and night, and secular motion of the earth controls the season, Ritu Parivartan, right? So this axis of rotation by which force going to be tilted. If it is tilted abnormally, then automatically the Ritu Parivartan will be uncontrollable to us, right? So Mother Earth is subjected to the history by at least 12 mega earthquake of 9 magnitude, okay, 9 magnitude that generates energy equivalent to 50 megatons explosive of TNT. You imagine that 50 gigatons of explosive of the TNT. So this has the power to tilt the axis of rotation. It was tested in the 2004 North Sumatra Andaman tsunami-genic earthquake. It was tilted for 0.02 degree from its axis of rotations. But Mother Earth is very kind to us because this observes a lot of the seismic energy occurring inside. Some part of the energy come to the surface, and that was the most disastrous. So it tried to heal up, come to its original conditions. That's why the changes was not havoc. But in those days, it might be happened that first earthquake when the Pangaea was broken into northern Laurasia and the Gondwana land, or Laurasia and Gondwana land, that was the first day of the earthquake. You can imagine that how much energy generated in that time. Okay, so there is in that time there is no instrument and all. So GeoRisk is now here challenging topic that we have to adopt the modality mechanism, that we have to adapt how to stay, we have to do how to control. And it was well said that during the earthquake or the landslide or in the GLOF, if the protection will be taken, the losses will be minimized. Just like in examination preparation, if you are doing a regular classes, you can sure that in the 50% I have going to pass. But you are not attending classes, you are not doing preparation, your common sense cannot help us, right? In disaster management cycle says that the pre-disaster, the during disaster, post-disaster, and boundary is 50-50%. So we are dependent that our post-disasters, all machinery will work for us? No. We have to do the prevention and preparedness, take precautions, take awarenesses and our knowledge bank so that the losses can be minimal, or it will be contributed that we will be prepared for that. And it is well said that it is the poorest and worst structure that can kill the people. It is not the earthquake that killed the people. That's why the Japan is safer from the earthquake, which is located at juxtaposition of the 4 plates. And we are only crying that we were in the Himalaya, Eurasian plate and Indian plate colliding, and the magnitude earthquake is occurred in the Himalaya. Of course, 8.7 is the biggest earthquake in the Himalaya in the Indian scenario. If you see the Shillong earthquake as well as Lohit earthquake, in the Arunachal earthquake. But Japan is located at juxtaposition of the 4 plates. The minimal cut-off earthquake is 5.6 magnitude. But what they did, they are not able to predict the earthquake till today because they are not knowing, or we are not knowing, the earthquake genetic mechanism. So what we are doing, we understand that earthquake occurring because the prediction takes the 4 stages. Out of these 4 stages, 3 stages we crossed. We have already demarcated, anticipated, already justified that this earthquake zone is there. But we cannot predict the earthquake in terms of or with reference to the authentications of the time, its locations, latitude, longitude and depth, and its size, how big it is there. And that's why you are working. So Japanese thought in this way, late earthquake study can going on, but we develop the earthquake risk resilient structure, where the role of the civil engineers, architects and all engineer community come to the picture. But most of the structures are built on very well built structure without taking consideration of the foundation of the building. There is a lot of the evidences that you can see that well built structure is just raised to ground, just like elephant take the one side, right? But that means the foundational design is not taken into consideration. And this is the foundational design taken by the geoscientist, that they design in such a way that maximum energy at the foundation will be scattered, dissipated. It was the attenuated, that was the diffracted, so that maximum energy cannot push to or cannot allow to the pass to the building. So there is no destruction. If destruction take place, it was the minimal. So all these solutions is now engineering solution available with us. That's why the critical structures, all infrastructures, even the submarines, the nuclear plants, the hydroelectric plants, we are doing. And India is doing the most highest dam in 300 meter concrete dam in Debang in Arunachal Pradesh in zone 5. It is a seismically risk resilient. It is done by us, by the technology that we can put the earthquake prone zone in an infrastructure in such a way that earthquake shaking frequency cannot match to the shaking frequency of the structure. So there is no resonance, there is no destruction. That's why world says that let earthquake happen, we will be safer through our, like a kavach, like equal to protecting device, just like rain is falling, but we have to go out by taking the umbrella or raincoat. Similarly, let earthquake happens, our kavach and our protector is our earthquake risk resilient structure. And that's why the India is pouring billions of the dollar, and we are the NCS, National Center for Seismology, is the nodal agencies to generate the outcome for the new building design code, which is based on the seismic microzonation. It is not zonation, because the zone is not, it is just a crude zone, right? Engineers think that the PGA value in their particular zone is everywhere same, but it's not like that. The PGA value, each and every grid is changing because it is a soil property. where soil is stiffness coefficient may be changing from one place to the other. That's why we try to give a lot of the parameters through seismic microgenation. Tomorrow it may be the nanogenation, day after tomorrow it could be the femto and picogenations, because you want a detailed information at each and every closest grid. And that's why we are going to have a new building design code, first for the strategic cities of the country having population more than 5 lakhs and more than 5 lakhs, falling in the zone 3, 4 and 5, to zonify the all zones in such a way that detailed information can be obtained. This is the target of the country, to make India as the earthquake risk resilient by 2047, when the India will be developed and Viksit Bharat. So this is the things is going on. So I congratulate the organizers who has taken the very up topic to doing that. I have the presentations of the slides, but I think you will be not allow me to speak more. If you allow me, I can present my slides to you to showing all the things. Thank you very much for inviting me. I'm sure that this is the deliverance in this conference is going to add a new dimensions in the policy planning, what the India is doing that. Thank you very much.
Thank you, Dr. O.P. Mishra, sir, for delivering such a knowledgeable keynote address. Moving forward, I would be highly obliged to introduce Shri Vivek Srivastavaji, a 1989 batch IPS officer of Gujarat, is the Director General of Fire Services, Civil Defense and Home Guards under the Ministry of Home Affairs, Government of India. With vast experience in internal security, intelligence and disaster management, he previously served as Special Director in the Intelligence Bureau, contributing significantly to national security and emergency response frameworks. He was also the Superintendent of Police of Bhuj during the 2001 Gujarat earthquake. I would like to welcome sir to deliver a keynote address.
Good morning, everybody. Professor Vijay Rani, Vice Principal, Hansraj College, my alma mater from where I did my physics honors. Dr. Debulina Kundu, Director, National Institute of Urban Affairs, who is the co-organizer of this conference. Dr. O.P. Mishra, Director, National Center for Seismology, and Advisor and Head of Seismology and Geosciences, Ministry of Earth Sciences, who just delivered such a enlightening and actually a very interesting lecture, which will actually fit into one of the main presentations which this deliberations would be having. And Shri Rakesh Jha, CEO and Executive Director, CDPRR. Ladies and gentlemen, esteemed guests, and if I may say so, fellow experts. I am honored to be speaking at this conference, which brings together leading researchers, policymakers, and practitioners to discuss the critical issues of glacial lake outburst floods, earthquakes, and landslides. These natural hazards pose significant threats to communities, ecosystems, and economies worldwide. Rising temperatures are accelerating glacial melting, increasing the risk of GLOFs, earthquakes, and landslides. These earthquakes and landslides especially can have devastating consequences, as we have seen in recent years. The Himalayan region in particular is vulnerable to these hazards due to its unique geology, climate, and demographics. According to studies conducted by the national agencies as the National Remote Sensing Center, Central Water Commission, and the GSI, along with international organizations like the International Center for ICMOD and the UNDP, the Hindu Kush Himalayas contain approximately 7,500 glacial lakes spread across the Ganges, Brahmaputra, and the Indus basins. Many of these lakes are deemed hazardous due to their increasing size, unstable moraine dams, as was mentioned by Dr. Mishra, and changing climatic conditions. The region's fragile ecosystems, dense population, and critical infrastructure make it essential to develop effective strategies for predicting, mitigating, and adapting to these risks. Today, I want to emphasize the importance of multidisciplinary approach to addressing these challenges. We need to bring together experts from various fields: geology, hydrology, seismology, ecology, engineering, economics, and social sciences to develop a comprehensive understanding of these hazards and their impacts. We also need to recognize the critical role of local communities in disaster risk reduction and management. In this connection, I would also like to emphasize on the important role played by first responders. In any natural disaster, which I have had the experience, unfortunate or maybe fortunate to have experienced the Bhuj earthquake, it is actually the immediate response in the golden hour. It is the people who respond immediately, who are actually the firefighters, the local police, the civil defense volunteers, the home guards, and any other person who are there, who actually lead to the maximum lives actually which are saved during that. The specialized agencies, they take their own time coming, but by that time the major damage and rescue is actually done by that time. So we should actually also emphasize on equipping and training the local people available there. Also, the traditional knowledge, expertise, and participation are essential for developing effective early warning systems, evacuation plans, and emergency response strategies. Furthermore, I would also want to highlight the need for regional cooperation and trans-boundary collaboration. The Himalayan region spans across multiple countries, and the impact of these hazards can be felt across borders. We need to work together to share knowledge, expertise, and resources to address these common challenges. Having said that, I want to particularly dwell on two issues which are associated with predicting these natural disasters, that is their predictability, and mitigation measures with respect to especially GLOFs, earthquakes, and landslides. Now, if we look at the predictability of GLOFs, earthquakes, and landslides, they vary due to differences in the underlying mechanisms, data availability, and modeling complexities. Actually, predictability is very important. So that is why I actually wanted to dwell on that. One is regarding to GLOFs. GLOFs have a very high or moderate predictability. The reason for this are many, because of increasing access to remote sensing technology, field observations, and numerical modeling. The second thing is that there are also identifiable precursors to GLOFs. These include changes in lake water levels, glacier calving, and icefall. These can actually be precursors to a GLOF. And the third is, which is actually peculiar to GLOFs, is their limited spatial extent. GLOFs typically will affect localized areas, making it easier to focus and to predict. Coming to earthquakes, which actually I experience, it has very low to moderate predictability, as was actually being mentioned by Dr. Mishra. They are very challenging to predict accurately with current methods being offered. So as he was saying, while two things which Dr. actually Mishra pointed out was that the earthquakes themselves do not kill. It is the falling debris and the houses which actually kill. The second thing is, even though there may be very severe earthquakes, if we actually follow the building code, the national building code, etc., and of course, it is not only limited to the risk zone of zone 5 or zone 4, but also towards the soil types, etc., which was actually being mentioned. So if we follow that, we can substantially actually reduce any damage or casualty because of the earthquakes. The case in point, as was pointed out, is the case of Germany, which actually faces number of earthquakes, but where the casualty is actually minimum. Even their train systems, Shankai systems, which actually move at close to 300 kilometers per hour, they are also had been made actually earthquake proof. At the first, once it is detected, they actually stop. So there has been in Japan no casualty in train accidents, even when they have been actually faced with very high energy earthquakes. The reason for this predictability is actually the very complex underlying mechanisms for predicting an earthquake, which actually it involves intricate processes making it very difficult. Also, the earthquake, the extent is very large, and one cannot identify the exact source and the what will be. So that is the earthquakes. They are one of the most unpredictable disasters which we may actually have to prepare for. The third is the landslide. So it has actually moderate predictability. They can be predicted with moderate accuracy using a combination of geological, hydrological, and environmental factors. Now, identifiable precursors, they are also there. Changes in soil moisture, rainfall intensity, and land use can serve as a precursor to landslides. If some hills have been denuded, a lot of rainfall has happened, we can generally expect that landslides can actually happen there. Their extent is also variable. It can affect small localized areas, large areas, depending on the specific event. So in summary, as far as predictability is concerned, it can be actually in a continuum. Very low predictability for earthquakes, moderate for landslides, and from moderate to pretty high for GLOF events. Now, mitigating strategies, that was the second thing which I said, because that is the most important. It will make the environment resilient so that the full impact of the disaster is actually mitigated to a large extent. Now, GLOF mitigation technologies, number of there, I'll just mention some of those, and I'm sure in the technical discussions which will happen in the day or maybe in the next day, that will be discussed in greater details. One is lake siphoning. Now, this is basically, as it mentions, the lake has to be, the water level of the lake can be reduced by siphoning of the water. This type of technology is being used in Peru. So actually, we can actually learn from other countries also. Tunnel drainage system is there. The third would be dam reinforcement, which actually happens because of the moraine dam. So we can actually reinforce there. Early warning systems have been used very effectively, especially in Switzerland, because their technology is developed. We are also actually doing that. A number of GLOFs, which are likely to actually burst in, there may be a tendency. So we have gone and actually established those early warning systems there. So we will actually know regarding the temperature, whether the snow is melting or not, and whether there is a likelihood of a GLOF event or not. And the last is actually the artificial lake drainage, which we can use by using explosive, etc. Before it becomes into a big event, if it is a small, it can be drained. Earthquake mitigation technologies, this was actually done in Bhuj post-earthquake when the major thing happened. One is the base isolation techniques while making a building. So the new hospital of Bhuj, actually when the earthquake took place, the Bhuj hospital collapsed, and 250 doctors and patients actually died there. So subsequently, when the hospital was made there, then it has been made with base isolation techniques. So it can actually now, it is said it can withstand an earthquake of 9 Richter scale. So basically, there is a need, especially in risk zone 4 and zone 5, to have critical infrastructure which are resilient, especially to earthquakes. Energy dissipation systems are also there. Use of advanced materials or use of materials which will not lead to actually loss of life, like use of wood, etc. That can be actually be resorted to. And building information modeling, it is utilizing BIM to design and analyze buildings for seismic resilience. So this is the use of technology, whereby if we use technology, we can make our structures more resilient, especially to earthquakes. Third is landslide mitigation technologies. So one of the few things which are being done everywhere, which you may say, is the slope stabilization. These are implementing measures like retaining walls, anchors, and geotextiles to stabilize slopes. Another would be drainage systems. Early warning systems also there. These are establishing monitoring systems that detect changes in soil moisture, slope movement, and other factors, providing early warning for potential landslides. Geosynthetics is also being used. It's like geogrids, geotextiles, and geomembranes to reinforce slopes and prevent landslides. And the third is using technology. Primary in landslides is the LIDAR technology, utilizing light detection and ranging to create high-resolution topographic maps identifying potential landslide areas. Now, these mitigation technologies can help the impact of GLOFs, earthquakes, and landslides, protecting communities, infrastructure, and environment. In conclusion, I urge you all to continue working together to advance our understanding of glacial lake outburst floods, earthquakes, and landslides. Let us develop effective strategies for mitigating and adapting to these risks and work towards creating resilient communities and ecosystems, especially in the Himalayan regions. Thank you, and Jai Hind.
Thank you, Vivek sir, for your enlightening experiences and knowledgeable words. Lastly, I would like to welcome and introduce Mr. Rakesh Jha, Group CEO of ResQore and CDPRR, who brings extensive experience in journalism, marketing, and operations. A former CEO of Sharpen India, he previously had a 17 years journalism career, contributing to major publications like The Times of India, Hindustan Times, and Deccan Chronicle. He currently leads multiple ventures, including Playzone Media Management Private Limited. I would like to welcome him to deliver a vote of thanks. Thank you.
Good morning, ladies and gentlemen. First of all, I would like to thank Vivek Srivastava sir, Director General Fire Services, Civil Defense and Home Guards, who has taken out his time to grace this occasion. I thank Dr. O.P. Mishra sir, Director of National Center for Seismology. Thank special guests and our co-organizer, Dr. Debolina Kundu ma'am, Director NIUA, Professor Vijay Rani ma'am, Vice Principal Hansraj College, esteemed dignitaries, distinguished speakers, delegates, and participants. Thank you all for coming to this conference. It's a great honor for me to extend a heartfelt vote of thanks on behalf of ResQore Technologies and CDPRR at the successful inauguration of GeoRisk 2025. My greatest gratitude to Vivek sir for sharing his expertise and insights into strengthening national disaster preparedness. His insights on preparedness and mitigation, I think it's well taken by everyone present here. And we have heard a number of times from him about his first-hand experience on as a superintendent of police in Bhuj during the 2001 Gujarat earthquake. I think we learn from his experience and do a bit in a capacity. Thank you, Dr. Debolina Kundu ma'am and Dr. O.P. Mishra sir, for your valuable insights into disaster preparedness. I think we will have more of such talks in the sessions to come. And thank you, Vijay Rani ma'am, for being a strategic partner and helping us in organizing this event. It was a great help from Hansraj College. And I would like to thank all the delegates and the participants who are here. I think without them we can't make this conference a success. And I think, you all get to learn, something from our esteemed, speakers and panelists. And we create a networking platform where, we can take this, forward, from here. Thank you all, for coming here.
As we conclude this inaugural session of this GeoRisk 2025 conference on GLOFs, landslide and earthquakes, we would like to express our heartfelt appreciation to our esteemed guests. As a token of our gratitude for their presence and commitment to this critical field, we invite them to accept a special memento. I request Professor Bijay Rani, Vice Principal, Hansraj College, Strategic Partner of GeoRisk 2025, to present the memento to Sri Vivek Srivastava, IPS, Director General of Fire Services, Civil Defense and Home Guards. Sorry, photo. I invite my colleague, Sri Rakesh Jha, Group CEO of ResQore and Medaletics and Executive Director of CDPRR, to present the memento to Dr. Debolina Kundu, Director, Additional Church, National Institute of Urban Affairs. I once again request Professor Bijay Rani to present the memento to Dr. O.P. Mishra, Director, National Center of Seismology, NCS, and Advisor, and Head of Seismology and Geosciences, Ministry of Earth Sciences. We now invite all our distinguished guests to join us for a group photograph. Ma'am, please. I request Rakesh Jha to present the memento to Professor Bijay Rani as a special token of our gratitude.
This was not required.
Thank you. Following this session, we warmly invite all our delegates, participants, and distinguished speakers to join us for high tea outside the conference hall. Thank you.
Session Chair and Moderator, Dr. Surya Prakash Sir, Professor and Head, Geometeorological Risk Management and Divisional NIDM. I request all the speakers to be here. Dr. Surya Prakash Sir, Dr. Sandeep Singh, Dr. P.K. Joshi, Professor, Shri V. Uday Kumar, and lastly, Group Captain, Dr. Rajiv Patni. I would like to welcome Dr. Surya Prakash Sir, Professor and Head of Geometeorological Risk Management Division, National Institute of Disaster Management, Ministry of Home Affairs, Government of India. He also leads the CBRN, Chemical, Biological, Radiological, and Nuclear, Industrial, and Cyber Disaster Risk Reduction Divisions. In addition to his roles at NIDM, Dr. Prakash serves as the National Coordinator for India at the National Associations for Promoting Geoethics in the Board of Representatives member at the National Consortium of Landslides. I welcome you, sir.
Thank you and welcome to the first technical session after the inaugural, wherein the dignitaries of the dais, they have shared their experiences related to their own hands-on experiences with the real-time events. Though I had a presentation, I thought I would start with the presentation, but then I feel that it's more important to share with this diverse gathering about the disaster situations in the country. वो कहते हैं, किसी शायर ने कहा है ना कि जगाना आता उसे कई तरीक़ों से, दरों पर दस्तक देने खुदा नहीं आता, पड़े रहो सहमे हुए यूं ही अगर हवाओं के पर बांधना नहीं आता. तो ये आर एक्चुअली गेटिंग लॉट ऑफ अवेकनिंग रिमाइंडर्स फ्रॉम द नेचर. I'll cite examples from my own life. I started working on disasters way back in 1990. It's almost 35 years now. The first disaster I dealt was a landslide which was affecting an ITBP camp on a national highway going towards our strategic borders to China. We are dealing with that problem. That what are the causes, what are the factors affecting, what are the directions and magnitudes of the movements, how do we control those landslides. But then suddenly on the early morning of 20th October 1991 at around 2:53 am, we had a jerk of an earthquake in Uttarkashi district where that landslide was located. I used to go almost every month for studying that landslide and mapping that landslide as well as monitoring that landslide. But when this event happened on the earthquake, I was working at that time Central Building Research Institute of CSIR and was connected with Department of Earth Sciences. The DM of Uttarkashi actually connected with the Department of Earth Sciences, which had a seismograph, and asked for that what's the magnitude of the earthquake and what has actually happened. But then there were a lot of casualties. It was an earthquake of magnitude 6 point, moment magnitude was 6.8, and we had around 800 casualties. Being from Central Building Institute, at that time there was no Uttarakhand, it was UP. So UP government from Lucknow, they sent a letter to the director CBRI to propose temporary shelters. I still remember all the scientists, they got together to discuss that issue, that how to provide temporary shelters to the victims of the earthquake. Till then, this kind of approach had never happened. World Bank stated, we want to provide you support on the condition that if you will submit a technical report. But no one had actually done any kind of damage assessments for the earthquake in a technical manner in the past. So there were no examples for us to follow. We devised our own formats. The structural engineering division of CBRI actually worked on it, that how these different structures, they can be actually monitored for the impact of the earthquake. And not only that was the challenge, it was also a challenge that how to actually recover those buildings, either retrofitting, re-strengthening or reconstruction or relocation as per the degree of the damages. So everything was a new challenge, and we took examples from various sources and started working on it. So this was the beginning when I started from landslide, went into earthquake, and subsequently there was another issue which came up, was a Gyansu Nala flood. So the multivariety of the disasters actually brought into multi-hazard approach. And I realized it's not enough to study just the landslides or the earthquakes or the floods. There have been several other instances. I will just go through because I wanted to cite to that how life teaches us about disaster management. 1993, we had the Latur earthquake, which was an unexpected in a peninsular area, which was in zone 1 and 2. So therefore, we were not expecting. Earlier we had 5 zones. Now after the Latur, the zone 1 and 2 were merged together, and now we have only zone 2 to 5, 4 zones. So this was another surprise that came across in September 1993. Then we had another event, 97 earthquake in Jabalpur, 22nd May, followed by one more earthquake in Uttarakhand. Currently, Uttarakhand actually came into existence on 9th November 1999, but this event happened on 30th March 1999, Chamoli earthquake. However, the people had become sensitive. They learned how to act in earthquake-like situations. So while we had more than around 800 casualties during Uttarkashi, during the Chamoli earthquake, though the magnitude was almost similar, we had only 100 plus deaths. But in Latur, we had more than 9,000 deaths, because they were caught unawareingly, unprepared and uninformed. They never expected the unexpected events of that nature. Now while we were working on this, because topic covers other areas too, I still remember while I was continuing my work on landslides, we came across a major landslide on our route to Kailash Mansarovar. It was midnight of 17th and 18th August 1998. More than 200 plus people, they got killed while they were resting at a place called Malpa. And a big landslide happened and engulfed all their lives in the early morning of that 18th August 1998. There are many other examples. That's why I'm trying to drive you to those events which were teaching us lessons, but we never learned. I still remember 18th September 1880, during British periods, when a landslide happened in Nainital, Sherka Danda Hills, and killed about 151 people, including 43 Britishers. They started monitoring that landslide in India way back in 1880 itself. There are many more such events which had taken place. There was a river blockade in Brehiganga, which was blocked in 1893 and breached in 1894. That was also monitored. They could prevent the loss of human lives by adequate, proper mechanisms for monitoring those events, and also alerting people to evacuate from the affected areas so that no loss of life should happen. But in the current cases, despite all our advancements and studies and involvement of so many people, now the casualties are also rising. The number of events in terms of their frequency and intensity are also rising. I just told you about 1998. Recall back the event which happened on the 16th June 2013. I was there in Uttarakhand from 11 to 17th June. I responded back after that also. We had casualties of more than 5,000 people. Because the Gandhi Sarovar, which we often known better as now Chorabadi Lake, it got burst. So there are a lot of such events which have been happening in the past. And if I come back to the recent times, the South Lonak Lake in Sikkim, which happened in the early morning on the early morning of 4th of October 2023. It killed so many people and affected the power project Tista 3 and many highways, bridges and other structures. So there have been lot of such events which have been happening. I can count you many of them. I dropped at 99. I still remember Vivek Srivastavji told you about the 26 January 2001 earthquake which struck at 8:30 a.m. while students were going for the Republic Day parade. And we had huge number of casualties. I still can recall the 2004 tsunami event which occurred in the Indian Ocean and affected around 11 to 13 countries. Lakhs of people lost their lives because they were not aware whether a tsunami can happen in an ocean like Indian Ocean. They were expecting it in Pacific Ocean. We covered it. We did lot of efforts. If I come to the practices that we evolved over a period of time from 1998 onwards. I still remember the government of India after the Malpa landslide actually constituted 3 committees. And later on, at that time it was Ministry of Agriculture which actually formed a high power committee under the chairmanship of the then Secretary Ministry of Agriculture Shri J.C. Pant. All the system which has come up actually are the recommendations of that committee which were submitted in September 2001. So we were evolving and we struck again another earthquake, I remember 8th October 2005 in Kashmir. If I recall back again in Sikkim, 18th September, it was 2011. I was sitting at my home in Delhi, it was around 6:10 p.m. I felt the jerk of that earthquake which occurred on the Indo-Nepal border. So imagine how much energy must have been released which travelled from Sikkim to Delhi, and you can feel the shaking at your home. So there have been many such events which have been recalling. If I recall back even the 2011, the Japan triple disaster. I remember I had 20 experts from Japan dealing with earthquakes, landslides and tsunami as well as GLOFs. We were talking to them on 10th March 2011 in Sikkim at Gangtok, and then we got a report that there is an earthquake of magnitude 7.6. It was around 5:30 p.m. at that time. I spoke to my friends from Japan and they said, Surya, please continue the meeting. I was surprised. Perhaps these people don't have attachment to their family. I just told them, you can call your family, friends, near dear ones, so that you can know about them. They said, no, continue the meeting. Anyway, it was their concern, not my concern. I was only to inform them. But then 11th March, I remember 2011, it was 11 a.m. at Delhi. I returned to Delhi, going back from airport to the home. I learned there is a tsunami of more than 20-meter height. I called them back. See the level of confidence they had and the clarity they had. I was told all Japanese went to the airport, coming back to the embassy, and they will return to their country. Later on, they wrote me back, Surya, we were prepared against an earthquake of magnitude 8 or even more, and we knew there will not be any casualty. Really, no casualties did happen on that day of 10th March. But we were not prepared against tsunami of more than 12-meter height. So we were expecting devastation. I can still recall the earthquake which happened in 2001 on the same month when 1995, 17th January in Kobe. They prepared themselves for earthquake resistant structure by having timber buildings, because they don't suffer much and they don't get easily broken up or collapsed. But then there was leakage from the gas pipelines which burnt those timber buildings, and more than around, I think at that time, 5,500 people got killed. And if I recall the timing of the events, it was most of these events happened from 00:30 hours to 4:30 hours, between that period only, or 5:30 hours, when most of the people are in a sleep mode. They are not awakened. So until and unless we actually train ourselves and practice mock drills and learn that what to do even if I am asleep, the disaster do not affect me. You cannot avert all the disasters, particularly events like earthquakes. So we have no option but to prepare against them. But landslides, GLOFs, they can be monitored, they can be even prevented, mitigated, or we can issue an early warning with respect to them. So there are a lot of things. I think we have a lot of speakers, but my only purpose to state is now not to scare you, but to make you aware that we have realized this at the national level. We have started with programs. We had National Earthquake Awareness Program for the engineers, for the masons, for the architects, and also recently we have got from our mitigation funds approval of the National Mitigation Program on GLOF mitigation, right? And another program has also been actually approved by our ministry on National Landslide Risk Mitigation Program. The National GLOF Mitigation Program is around 150 crore across the country to set up pilot examples of how to mitigate GLOF related disaster risk and enhance resilience of the communities. While the landslide risk management program is amounting to about 1,000 crores of rupee. So lot of landslides. We have landslides to the extent that the total area which is covered by the landslide is more than the total area of some of the countries, like Italy. We have so many, but the data set, the information is still lacking. So a lot of things we need to do. We have started a program now on landslide early warning systems. We have also set up our nodal agencies. For landslide is Geological Survey of India. For GLOFs it is Central Water Commission. For earthquakes, Dr. O.P. Mishra was there from National Center for Seismology, who are looking into these issues. So with these words, I would say that we need to actually become more aware, informed and prepared rather than awaiting for the disasters. Let's act proactively, enhance this information sharing at all levels with everyone. We have through the Sendai framework, I still remember on from 14 to 18th March 2015, we had the third World Conference wherein we declared the 4 priority actions and 7 targets. All these were actually emerged as part of global discussions and deliberations. Most of these things are available on the internet. I need not elaborate more on it, but I would urge that let's meet the challenges. Resources are always falling crunch and scarce in times of disaster situations, and there are a lot of new challenges, complexities and chronicities in these events which need to be understood. And if we keep the courage and the confidence and our credibility of our works, we will be able to meet those challenges. किन्हें कहा ना, मंजिलें उन्हीं को मिलती हैं जिनके कदमों में जान होती है, पंखों से कुछ नहीं होता यारों, हौसलों से उड़ान होती है. So we have to deciding our way, and those who decide to go ahead, they will find their destination. As our national policy states, zero casualty, disaster free and resilient nation. तो मैं लास्ट में यही कहूँगा, मंजिलें उन्हीं को मिलती हैं जो सफ़र अख्तियार करते हैं, ऐसे मुसाफिर को तो यारो रास्ते भी इंतज़ार करते हैं. So wish you all the best. Happy, healthy, safe and good quality life. Now, I think I have a duty to invite Dr. Sandeep Singh ji, Professor, Department of Earth Sciences, IIT Roorkee. Let me give you a brief about him. Dr. Sandeep Singh is a Professor of Earth Sciences at IIT Roorkee. His research focuses on Himalayan tectonics, igneous petrology, geochronology, and strontium isotopes. Maybe some of the words may be new to many of you. He has been in IIT since 1996. Dr. Singh has contributed over 50 publications and has been cited nearly 3,000 times. He has received several honors, including Boycast Fellowship in 2001 and INSA DFG Fellowship in 2003. I invite him for deliberation of his experiences, ideas, and innovations in the field of disaster management. Thank you.
Thank you, Dr. Surya. Learned audience, I am not going to talk about what should be done, but rather I am going to look at our vernacular, resilient, traditional buildings of the Himalayan region, which has been there, and they have witnessed many earthquakes in the Himalaya. Why they have withstand those disastrous earthquake? Because our ancestors, they knew that what are the effects of the earthquakes and how best they can absorb the movement within the building so that there is no casualty or no breakage. We got a project or a Center for Himalayan Studies where we try to document, because earlier the structures, they have been there, now older buildings are getting deteriorated and the practices which are there are waning away. So I'm just going to take you through this, and I hope I'll do justice to the traditional buildings which have been there standing for many earthquakes in the region. This is an exaggerated relief map of India, where you have the Indian plate, and then beyond that you are having the Eurasian plate, and there is a rise of Himalaya because of the collision between Indian plate and the Eurasian plate. And if you look at the Himalayan region, you have different lithotectonic units, starting from Shivaliks, or I'll put it Indo-Gangetic plain, and then Shivaliks, which is also known as the sub-Himalayas, Lesser Himalayan sequence, Higher Himalayan sequence, and the Tethyan Himalaya, and so on and so forth. And these all are separated by major tectonic boundaries. And these tectonic boundaries are basically responsible for the earthquake in the Himalayan region. So if you look at the Himalaya as such, it started, the Indian plate moved out from the Antarctica plate and they moved towards north and they collided with Eurasia and got the Himalaya approximately not later than 57 million years. There has been research by our group which constrained the timing of the collision. So if you look at the movement, initially it was a northward movement, and then once it got touched into Eurasian plate, there is an anti-clockwise rotation, and which is bringing the Indian plate into the present situation. So if you look at the cross section of the Himalaya from south to north, you will find that there are many fault or thrust planes, which are like the main frontal thrust, main boundary thrust, main central thrust, South Tibetan detachment system, and the Indus-Sangpo-Sucha zone. The Indus-Sangpo-Sucha zone is the limit of our Indian plate, and beyond that we are having the Eurasian plate. So I'm not going into details of this. This is just to tell you how the cross section of the Himalaya looks like. So basically, what is happening when the Indian plate is moving and indenting with the Eurasian plate, you have the development of fault lines which are starting from north towards south. So that means there is a younging of the fault from south to north. And that is why if you start looking at the Himalayan frontal thrust is the youngest one. And beyond that we are having MBT. So most of the earthquakes, they are resulting along these main boundary thrust. And for that matter, the earthquakes can be caused either by volcanic eruption or tectonic movement along the fault. And the earthquake where it is generated, it is known as the focus, and then it comes up onto the surface, which is known as the epicenter. So the earthquake, which we are more concerned in Himalayan region, is caused by a sudden slip on a fault. It is basically the readjustment of stress within the earth. So there are many major earthquakes and there are minor earthquakes, like what Dr. O.P. Mishra was telling, that there are small micro earthquakes are also happening, which are causing the release of smaller stresses which are building up in the area. So basically earthquake release energy in wave form that travel through the earth crust and cause the shaking that we feel on the earth surface. So basically there are 4 kind of waves, that P wave, S wave, love wave, and the relay wave. The P wave and S wave, they are the surface wave, the body waves, and the love wave and the relay wave of the surface waves. So they are basically responsible for the earthquakes in any particular area. The love waves tend to cause the most damage due to their large amplitude. And the P waves have the least amplitude and they are the first one to arrive at the particular location. So we all are talking about different zones in the where the Indian plate or whole of the India has been divided. They have been divided into 5 zones. Earlier it was 4. Now the zone 1 is removed and we still have 4 zones like zone 2, zone 3, zone 4 and zone 5. They are based on the risk or the damage risk of that particular area. So that is why they have been divided into these 5 different zones, and they have a particular BIS standards to follow in this particular zones where you need to build the structures. So this is a location of earthquake and magnitude based on the catalogs, how the earthquakes are located or distributed in the Himalaya. So you'll find that mostly they are in these MBT zones, and there you are having some of the larger earthquakes which happened in the past. So there has been few earthquakes which are having magnitude more than 8. One of them is the Assam earthquake, where we have the movement of boulder of 1G. That means the boulder got lifted from the surface and brought to another place. So these are the accessible lines, which are basically based on the damages occurring in the particular area. So they basically represent the intensity of the damage in a particular area. This is for the Kangra earthquake, and this is for the Nepal-Bihar earthquake. So there has been historical earthquakes having magnitude more than 8. This is what our friend Dr. Suri Prakash was talking about, that what happened in the Uttarkashi earthquake in the year 1999. So this happened because of the heavy top buildings. Because that time the Teri Dam was being prepared, and the Saria and cement was available for the people to build their houses. So what they did, they had the normal house, and on top of that, what they did, they put these RCC slab. And when there was a ground shaking, the building got collapsed. So that caused more harm to the people than the other earthquakes, where the people were preparing their houses in a much better way. So if you're looking at the vernacular buildings in the Uttarakhand Himalaya, you'll find that most of the buildings, they are built by these wooden structure. Now it is very difficult to find the wood, but I think there are way to go ahead that we should find some alternative material to replace the wood, but follow the building practices which has been there, which we have looked at during our work. So this is a traditional multi-story building near Uttarkashi, a traditional hut made from wood, slate and mud. So what they basically do, that they put the slate on top of it. So all slates are lying on top of each other. They are not fixed one. So if there is an earthquake, they adjust themselves. So that means there is no collapse at all. Whereas if you look at this evolution of the building technology here, stone only temple, traditional Kumaoni house made from the stone masonry, and then concrete reworking of a traditional house. So at one location we can see all these 3 different kind of buildings over there. So basically if you see this stone masonry one, that you are having the stones, and then you have this wooden log on top of it, and there they have the slates lying on top of, at the rooftop. So basically, it is exerting the stress or the movement caused due to the earthquakes. There has been similar kind of buildings. It's in Himachal, it is known as the Kathakuni style, and in Uttarakhand, it's known as the normal traditional houses made out of the wood. So Kathakuni is a different kind of style where they are using the wooden plank and the stone masonry to build up the house. So now if you're looking at the modern way of making the houses, what is being done that on a slope, they are making the RCC pillar and building the houses. So this is not what is required nowadays. So you have to look at the situation, and you have to follow the there are BIS standards which one has to follow, which is not being done. So there is a need to do that in practice, basically. So basically, if you look at the detailed drawing of the vernacular building, which are the earthquake resistant structures, you have a column, and then you are on top of that, you are having this roof central plank. And if you find that they have been put up in a groove. So if there is an earthquake, they exert themselves over there, and there is no damage to the building, basically. So similarly, if you see a cross section over here, this building. So this is basically, it's not a fixed one. What is being done nowadays, that we are making our building a fixed one. So if there's a fixed one, if there is a movement, so it will bend. The whole pillar will bend, whereas if it is lying on top of it, they will move along that, and they will readjust themselves once the movement is over. So that is what needs to be done. That because we all know that the earthquake caused shaking of the ground, and the building resting on the ground will experience motion at its base. And from Newton's first law of motion, even though the base of the building moves with the ground, the roof tends to stay in its original position. Since the wall and column are connected to it, they drag the roof along with them. So that is what is happening nowadays. This gives the inertia force on the roof element, and if the roof has mass m and experience and acceleration, then the inertial force F1 will be equal to the ma, and its direction will be opposite to that of the acceleration, and which will cause the collapse of the building. So if you're looking at the another one, what is happening, that what they have done, they have given you enough space so that it gets adjusted when there is a movement during the earthquake. So the movable joints allows the solution to tolerate the movement of these earthquake horizontal movements over there. And if you look at this again, they are all having the similar, there is no fixed joints here in these buildings. And aesthetics, architecture, and science unite in a Himalayan habitat, which has led them to withstand many earthquakes in the area. And people are sitting over here with the roof having a groove with the central plank and beams holding the roof, and they are free to move along the groups as well. So, and it is the landscape that form the most spectacular heritage of this unique land. We hope that we all will be inspired to explore and help preserve the heritage of the Himalayas. Thank you.
Thank you, Dr. Sandeep. I think it would be better if we take questions at the end, and let's listen all to the speakers so that we can gather the information and experiences from their lectures and deliberations. So now next I would like to call Dr. P.K. Joshi. He is professor from School of Environmental Sciences, Jawaharlal Nehru University, New Delhi. His research focuses on advanced geospatial analysis and modeling, landscape and vegetation analysis, and impacts of climate change on ecological systems. Dr. Joshi has received several prestigious awards, including PR Pesharuti Memorial Award from Indian Society of Remote Sensing in 2014 and the Young Scientist Medal from Indian National Science Academy in 2006. With these words, I welcome him to deliver his lecture.
Thank you very much, Dr. Surya Prakash ji. A very good afternoon, namaskar to all of you. And given the topic to talk on and the time, I have tried fitting in few of the thoughts related to advanced geospatial modeling for multi-hazard risk assessment. So when we look this much larger topic, which is of great interest nowadays, the first question which comes to my mind is, what is multi-hazard risk assessment? Is it just knowing a geographical area which can have variety of hazards? Or is it knowing which hazard comes first and then which comes second, how seasonally it is distributed? Or is it something more? So to me, the first two questions which I posed, most of us, we know the answers. But probably what we don't know is the relationships which exist between more than one hazard. And the mechanism which are listed over there, these are the 6 potential mechanisms, but there could be an opportunity given a geography, given an environmental setting, and given the interaction with anthropogenic forces, there could be other kind of mechanisms. But at times, if we are actually interested to handle multi-hazard risk, probably we need to know how hazard 1 interacts with 2. There could be, hazard 1 is triggering hazard 2. There could be a possibility the outcome of hazard 1 is triggering hazard 2. There could be another opportunity where both are playing together and then there is a synergy between those two which are creating much larger havoc, or could be vice versa. So when we are looking at technology today, probably our interest is to look at how these hazards are interlinked and how a particular geography in a particular environmental setting is able to generate such type of hazards. And that is probably when we are looking at multi-hazard risk assessment, our energy needs to go in. Because, as Dr. Surya Prakash was mentioning, right from the Nainital example which he gave, today when we see country and the world, probably the human life loss has come to almost negligible. What is more concerning to all of us is the infrastructure and the environmental degradation. Still, the environmental degradation takes the second seat, but larger concern is for the environment, the infrastructure which is over there. So herein, one of the promising technologies come, which is combination of these 3 primarily, though there is ICT, though there is whole range of knowing the area and the processes over there. One is your Earth observation system. Typically, people call it remote sensing. It started from aeroplane, it went to the space, and then it has come to the drones. Now you are talking about EDTARs or in situ measurements as well. So you have entire range of platforms which is able to provide you data sets of varied nature and varied utility. Another is a system, geographical information system, which actually caters the handling of entire range of spatial and non-spatial data sets. Anything which could be known by location could be handled over here. At times, people were thinking as if somebody doing GIS is making a map. Probably map is one of the childs of GIS. You have many more children which are feeding the family of geospatial analysis. One comes predictive analysis, forecasting, pattern, trend, and all those kind of things. The another is GNSS, Global Navigation Satellite System. People have now started realizing the importance of GPS tool. We have gone beyond location-based services, and we wish to measure many more things. There is something called as UN Spider. If you look at the success, genesis, existence, and success of UN Spider, that is based on these three pillars of remote sensing, GIS, and GPS. We started with resource mapping. We did an understanding of environmental degradation. People talked about climate change using these tools and techniques. People talked about disaster management. Now we are venturing into disaster risk resilience. How can we reduce the impacts of the disasters which are over there? So, the entire landscape is changing very fast. You have variety of sensors which are coming into picture. When I say variety of sensors, these are not only different platforms, these are just not different spatial resolutions, but spectra, the electromagnetic radiation which is being used to capture such type of information. People are talking about going much beyond just the false color composite and just the spatial resolution of 20 meter and all. So we have actually crossed the limits of hyperspectral remote sensing. People have started talking about ultraspectral remote sensing and benefits of those into that. Simultaneously, the computational strategies are also becoming much better. Our data handling techniques, there is an entire family of artificial intelligence, machine learning, neural network, deep learnings, which are at the main stage and which are able to provide you analysis of data and information extraction for better understanding, so that what people talk about early warning systems, such kind of things could be mechanized in a much more fruitful manner. So taking an example of a watershed, today when we are looking at the word of geospatial technology, it is just not about monitoring Earth from the space, rather having sensors at different platforms. It could be IoTs, it could be LiDAR, it could be sensors, in situ sensors, which are measuring the flow of water, groundwater, surface water, or even variety of water quality parameters. When we look at this, so this technology from cryosphere to hydrosphere, entire spectra of resources, it is able to handle right from data collection, analyzing it almost in real time, and then generating scenarios or simulating multiple objective optimization techniques, so that better understanding through geovisualization could be done. Web portals are the common name nowadays. You have web services which are available with you to understand the things, to extract more information out of those. So the decision support system, which were most of the time being talked by policymakers and all, we are looking at smart decision support system. We are looking at the systems which are actually pinpointing and addressing the core issues of the hazards which are over there. This is a typical example of multi-hazard urban world, which we all face. One is congestion, one is intensification of urban areas, one is vertical limits which we are crossing. There are things like urban heat islands. There are things like nature-based solutions which are coming remedy to the urban flooding or other kind of stresses which are over there. There are hidden, environmental variables which at times crop up and bring larger issues related to water quality, related to air quality, which are very close to the urban hazards which we very frequently talk about. The kind of galaxy of sensors which we have, if one is able to optimally utilize the capabilities of those, one should be able to ascertain from where such type of what are the sources and what kind of spread patterns are there, and subsequently what kind of impacts are coming in. So when we move further in technology trends, and specifically to the topic like, GLOFs, landslides, earthquakes. So in the morning session again, Mr. Vivek Srivastava ji talked about, Dr. Mishra ji talked about, GLOFs are something which have actually come as a blessing to many of the people to understand how disasters could be monitored. There is something called as, I basically come from ecology background, and everybody who has heard of ecology, food chain, food web, and 10% law. This is something very common, everybody understands very quickly. If you look at how these things have actually come into picture, the scientists who actually talked about food chain, 10% law and all, they worked on lakes and ponds. And from there they synthesized the information which is across the terrestrial ecosystems and the larger super blue planet, super organism which we call about that validates there. So this GLOFs provides us such type of opportunities. These are the control areas wherein having in situ sensors, having regular monitoring, one should be able to understand what kind of risk those are carrying. Nowadays, people are just not mapping GLOFs. People are just not mapping glacier lakes. People are trying to assess the vulnerability of those with respect to the volume which it is, position where it is, and the kind of area which it is covering. And when I say area, it is fractal dimension of that. It is shape of that which can bring a higher degree of vulnerability than that of only where it is located in. So that kind of opportunity technology is able to provide us. When we talk about landslide, for quite good time, if you look at the atlas which was at what point of time prepared by National Remote Sensing Agency, and that was one of the milestone works which basically talked about Uttarakhand, and then lately they talked about entire Northeast India along the roads. So landslide analysis modeling, that is a proven place. And if you understand your environment, if you understand the effect factors over there, and if you understand what kind of interaction is there by virtue of presence of human beings, such type of modeling is not difficult. Earthquake poses a challenge, and earlier speakers did talk about that. But if you look at the work being carried out by Sunji Murai, who is considered as father of remote sensing in Japan, using the GPS technology, he has time and again exhibited the potential of technology to predict earthquakes. If you look at, Dr. Sandeep Singh might be knowing, professor जो remote sensing में काम करते हैं geosciences में, now he has retired. Saraf Sahab, what he did is he tried looking at land surface temperature and correlating it with earthquakes. We also tried doing a very systematic review onto that, and we could understand that if one is able to monitor, map such type of biophysical parameters using satellite data, one should be able to arrive somewhat very closeness to, if not predicting well in advance, but at least knowing the areas which are becoming hotter and which might result into earthquakes. So I wouldn't buy the argument that it is impossible doing that. The possibility lies on how do you utilize the available data, or how do you look into the newer edges of computational powers using artificial intelligence or using data cubes, and then analyzing and understanding those so that one can understand how earthquakes are being built in and then taking shapes. So there is a whole range of possibilities which exist. Now people have started talking about digital twins. AR and VR was already existing with us. People are talking about climate machine learning based models which can help us to understand how geospatial tools can actually provide a very strong datum to such type of multiple hazards or GeoRisk which exists around us. We are living in a wonderful ecosystem, which is able to just not provide you data set, but provide you whole range of analysis, visualization, and utility of such kind of things. So now people have started talking about quantum GPS, quantum remote sensing. People are talking about 5G enabled GIS. If you look at PMO, quantum computing and geospatial technology, these are the topmost priority there. It means things are actually changing, and right from the top level, people have realized that geospatial technology can bring a meaningful change onto this. But as an academician, I believe we need an ICON framework wherein I say integrated approach, coordinated processes, open science, and networked efforts. You talk about any of the natural hazards which has a multi-sectoral network, it could be solved through if one is able to understand such type of research needs and proper research questions to address those. The prevailing drivers are these 5. There is a lot which is happening in the country and rest of the world. You have Indian space policy, remote sensing data policy, geospatial policy. Industry is coming with much more welcoming style when it comes to startups and all. Technological advancements are taking place. Probably the evolution of user requirement is somewhere slightly weaker. You know, people who are at the helm of the affairs, they need to ask bigger, larger questions, pinpointed questions. Then the people who are handling such type of technology, they will definitely be able to position themselves to provide you the correct answer. So I rest over here. Thank you. Thank you very much.
Thank you, Professor Joshi ji. I know as a professor and faculty, we always take longer lectures than what we are supposed to do here. So I'm sorry I had to intervene in between. But now I have the privilege to call Shri Uday Kumar ji, who is DDG and Scientist G at NIC. He has done a lot of good works. I know him. Leads geospatial technology and services contributing to national disaster management, food processing, petroleum, chemicals, pharmaceuticals and biotechnology sector. With expertise in digital governance, he plays a key role in integrating technology for disaster resilience and infrastructure planning across the country. I welcome him to his sharing of experience.
Thank you, Surya Prakash ji. When professors speak, we practitioners tend to think that हमारे पास तो कुछ भी नहीं है, हम क्या बोलेंगे. जब उन्होंने सब कुछ बता दिया तो हम सिर्फ हमारे काम के लिए थोड़ा आपको अप्राइज कर सकते हैं. उसके अलावा ना टेक्नोलॉजी के लिए वी कैन स्पीक अबाउट द टेक्नोलॉजी बिकॉज एवरीथिंग हैज़ बीन मेड वेरी क्लियर बाय द renowned professors who are sitting on this dais. But as a practitioner of GIS, I have near about 19 years of experience, and perhaps I don't know whether you people know or not, we have a platform called Bharat Maps. This is powering all the government's geospatial applications, and we are supporting about 275 applications with our map services. Now with the change of geospatial policy, GSPDC is coming up with new terminology of creating UGI, but NIC basically was doing kind of a UGI for the last 10 years. We have Indian base map called NIC Street we have created. It's an Indian base map which is at 1:10,000 scale, uniform across India. We have digitized. Initially, actually, I'll just 2 minutes I will take to tell you a little about a little history about NIC's work. Planning Commission way back in 2006 has discovered that there is no uniform data available across India for e-governance applications, GIS data. Survey of India has the data, but it is in topo sheets, but it is not being used. So they asked NIC to develop a multi-layer GIS framework. That's how we came into being. And then this was enhanced in 2014 to 16, where we took it to 1:10,000 scale. We have created about 6 infrastructure layers, and we have prepared what is called Bharat Maps. So we have about many layers are integrated on this platform. And over the years, we have collaborated with various ministries like Department of School Education, Department of Financial Services, Department of Posts, MIT for CSC locations, Department of Food, Ministry of Health for locating the health facilities. And we are providing geospatial based services. And recent achievement of our division is bringing the Swamitva data into public forum. Swamitva data, perhaps you all know that about 3 lakh plus 3.4 lakhs it will become by the end of next year. Village Abadi areas are mapped using drones. And entire that data, actually it's a British legacy that India has an Abadi area which is not mapped over several decades, that wherever people were residing, Britishers never surveyed that area. So Government of India, because those are the residential areas which were expanding and leading to areas in Delhi like Laldoras. When you come to peri-urban to urban, you have a lot of challenges in land disputes and resolution of property disputes and all those things. So they said we will map all these areas and give all the residents right to have their own land. So that's how the Swamitva scheme has come into being. And about 2 petabytes of data is generated in the process. And that data we are now serving. We have about 1,50,000 villages of drone imageries we are serving. And we have created many applications which can be used at the Gram Panchayat level for preparation of Gram Panchayat development plan. And this can be used for many applications including disaster management, because we are identifying what kind of roof it is, whether it is a RCC roof, whether it is a tiled roof and all that. That will be very helpful for disaster mitigation and planning. You want to take some measure, you know that how many houses are there, quickly you can know how many houses are there, and you can do. Similarly, the road network within a village we are mapping, and we are also telling people because of these roads, your ambulances cannot come to your place, your disaster vehicles, fire engines may not come to your place, so that people will realize and try to organize their habitations in such a manner that it becomes more resilient in that sense. So many applications we have developed, and actually we are using artificial intelligence, like Sir was mentioning that this is the era of artificial intelligence, and we are using artificial intelligence for feature extraction of these Abadi areas. This is about roughly by the end of 2026, about 2 lakh square kilometers of land, drone imagery will be available on our platform called Gram Manchitra, and with many tools and many features extracted which can be utilized by people for doing one side GPDP planning, Gram Panchayat development planning. The other side, they can use that data for disaster resilience and risk reduction. Actually, way back in 2012, I have also developed, just because this is a disaster context, we have developed, BMPTC publishes what is called a Vulnerability Atlas of India. It's a big, huge book prepared by professors like who are sitting here, There is a group of people who sit and identify what kind of disasters is there, and they bring out a volume which is about, for each district there is a 2-page document, and they assess what is earthquake zonation, what is wind zonation, what is flood zonation, and all these are integrated into that atlas. Way back in 2012, as part of a project given by NIDM, we have developed a digital vulnerability atlas of India, and it was launched, it was available, where the housing vulnerability is integrated along with the different disaster zonations which are integrated, so that for a particular district you can clearly know if some disaster happens, how many households are affected and all those things. And also you know that what is the vulnerability of that district when you see them at a glance. So these things we have developed. I think it is not in use right now because as the technologies change, it needs to be maintained and it needs some funding. Because of lack of funding, we couldn't take it forward, but it's a good application which can be taken forward and which can be used. So with these words, I would like to say that the Bharat Maps platform itself can also be used for doing any disaster mitigation or post-disaster if you want to identify which area is affected and what kind of measures you need to take. So all that data sets are available. We have recently developed a disaster decision support system, as mentioned by Joshi ji, for Parivesh. Parivesh is a single window system for giving all permissions, environment permissions. So there are 4 permissions, which is environment clearance, forest clearance, wildlife clearance, and CRZ clearance. So all these things we have prepared. We have taken about 60 layers from our platform. We have also taken data from other sources, curated that data. FSIS data also we have taken, and we have created a decision support system for forest officers for giving the permissions. There is a Lafarge judgment which says that how these things need to be analyzed. So we have incorporated all the Lafarge judgment guidelines into this application so that people can use that application. District forest officials and divisional forest officers can use that information for identifying whether a project has to be sanctioned or not sanctioned. So that is being now taken to next level, where we can have a kind of a green, orange, and red zones for environment grant. That is another work which we are doing. Just I thought that I will share that. Thank you. I thank the organizers for giving me this opportunity. It's I am humbled by our researchers and professors on the dais, because I am only a practitioner. I learn from them, I learn from their work, and we try to deliver something for the public. Thank you.
Thank you, Udayji. He's a very polite person. He did lot of good works. Most of the studies they are done on 1:50,000 scale, but he has produced Bharat Maps on 1:10,000 scale, which is a big task that he was assigned and he completed. Now I would like to invite Group Captain Dr. Rajiv Patniji, Founder and Director of Parar Consulting. He has specialized in health, healthcare and hospital management, a veteran of Indian Air Force with over 30 years of leadership experience. He is an alumnus of AFMC, AIMS and IIFT, focusing on strategic healthcare solutions, policy advisory and hospital resilience. I welcome him for the lecture.
Uh, Thank you very much, sir, for your kind words. First of all, I'd like to thank ResQore and CDPRR for inviting me to this amazing galaxy of experts. I was listening to the fascinating talks delivered by Dr. Sandeep Singh, a call to the roots, once again, if I may say, a remote sensing, and the fascinating work being done by Shri Udayji. And also the speakers in the morning, the keynote speakers, they brought in several perspectives of urbanization, etc. We kept talking about all kinds of things, the types of disasters, disaster mitigation. We talked about the role of different kinds of technologies, forecasting disasters, earthquakes. The focus here today is GLOFs, landslides and earthquakes. Making buildings resilient. However, when all these things fail, that's where practitioners like us, we come into play. So good afternoon, everyone. I'm a doctor. When everything fails, the Swiss cheese model comes into play. You've put in all kinds of guardrails. The disaster will find a way. We may be able to reduce the impact, but we can never eliminate the impact. And throughout the day, the first time a medical word was spoken, that was by Shri Udayji, who mentioned ambulances in his talk. So I'm going to give you some more of the medical aspect. And why should we talk about hospitals in disaster? A bit of good news for all of you. I had a very large presentation. I've reduced it to 4 slides. So, as I was saying, nature will always find a way. And any of these disasters is mostly a community event. But let's not forget, a hospital is part of the community, and it can become a hospital event. And that's when the disaster becomes a catastrophe. And this is the emphasis I will be putting during my few minutes of talk. So why should we be talking about it? When an earthquake strikes, most of the hospitals will also be razed to the ground. This is a systematic review of earthquakes from 94 to 23, 30 years across different continents, New Zealand, India, Turkey, etc. In this review, they found that 667 of 740 hospitals in the affected area were razed to the ground. Closer home, the Bhuj earthquake was mentioned here in the morning. A 250-bed hospital, all patients, let's not forget, the doctors, all the nurses, paramedical staff, and attendants and visitors of the patients who were there inside. Everyone was flattened by this. That's the impact. A hospital is not a residential building. It's not a family. You have patients. Per patient, at least 5 people are working in a hospital. And going by our Indian traditions, per patient, at least 1 to 2 visitors will be there in the hospital at any given time. Now, you will have a disaster, but hospitals are destroyed at a time when they are needed the most. What can we do about this? The National Policy on Disaster Management says hospitals are critical for the management of mass casualties. PAHO and WHO have mentioned something called safe hospital. A safe hospital is one which will not collapse in disasters. It can continue to function, is organized with contingency plans. Now, what are the elements in a hospital? There are structural elements which we can safeguard by all kinds of civil and architectural elements. We have the non-structural elements. All your almirahs, your equipment which is sitting around, these are the non-structural elements. And then you have the functional elements, which I will be talking about in a little more detail. Now, this is one slide where I would like to spend some time. When a community event becomes a hospital event, the hospital is finished. But let's assume there's something important happening there. Let's assume that the hospital is intact. This is the flow of patients. You will have initially the flow of patients is very slow. It will peak, and then you will have, this is the flow of patients. So this was in Gujarat earthquake. By the second or third day, it peaks because the roads are not there, ambulances are being brought in, people take time to reach the hospitals. Now, what happens in a hospital is most of your resources will be consumed on day 0 or day 1, because that's when the bulk of the patients have come. And these bulk of the patients are actually those with minor injuries. The ones with serious injuries will be coming by ambulance. They will be carried. They will be reaching you much later. The hospital needs to conserve its resources. And this also is a message to the planners that you need to bring in your resources at the earliest, because my hospital is prepared for my daily OPD and daily ward workload. I don't have medicines for mass casualty events. Another thing that happens in any disaster is my staff who are living in the community will also be affected. Their families will also be affected. So are you going to look after your family? You are a medical personnel, whatever your level of knowledge, or you are going to rush to the hospital to provide care over there. Usually, my people living in the community will become first responders to help the people around and organize the services and channelize them towards the hospital. So what a disaster does is, there is an attrition of my manpower. There is loss of morale. And most of the time people are working only on Josh. It's like the forge. You're just working on adrenaline. You're not thinking of anything else. I've had times when in my hospital, after 36 hours of working, I've had to tell people, "Ghar jao, apna bhi khayal rakhna hai aapne." That's the kind of commitment we see amongst the people when you're working on adrenaline. You're not thinking about yourself. Another thing that happens is mental health problems. NIMHANS has done a study, says roughly 30% of the affected population has mental health problems during any disaster. What is the nature of these mental health problems? You'll have anxiety, definitely, depression, sleeplessness, and some people will avoid total contact with any kind of community or any social contact. It's part loss, and part is the impact on your thinking processes, because the impact is so much. You're shocked. Suicidal tendencies also come in, and we need to look after this. Just to give you a glimpse of what happens in an earthquake, the bulk of injuries that come to me will be fractures, and the others will be head injuries, chest injuries, soft tissue injuries, nerve injuries, etc. 55% will be fractures. And this shows the distribution of the different types of fractures, different bones which will be affected. I'm sure we cannot do much about it. This slide shows what happens in different types of disasters, earthquakes, a lot of deaths and a lot of injuries. Landslides, on the other hand, will have lots of deaths because people are buried under the rubble. Lesser of injuries will be there because the force is a very different kind of force here. Now, before I conclude, there are a few things that I wanted to highlight here. One is, in the morning, the keynote speaker said we have to move from risk to resilience. How do you make a hospital resilient? It's by A, structural things that you can do. B, you have to have standards. C, prepare the people. Preparing, how do you do that? Is by mock drills, tabletop drills. The Forge keeps doing these things. So I was in the Forge, I was in the Air Force. We have done this thing routinely. Every quarter we do it. But this is something which is lacking, and that leads to the bigger tragedies. The hospital needs to be able to have a system of rapid recovery in place, because we don't have time to wail and cry. We have to be ready to receive the casualties. And then, if my hospital has collapsed, what do I do? We have to identify alternate spaces. Alternate space could be a tent, it could be a school, it could be a stadium, it could be a cinema hall, where I can at least handle and hold some minor injuries. We also need support from various places, and the support is, the first thing people think is, we need blood. Yes, we will need blood, but we also need water. We also need food. We also need people to come and help us with stretchers and carrying the patients. We also need tents. We need blankets. All these things are required. But the most important thing that we lose during a disaster of this nature is power. Almost entire medical systems and entire hospitals are based on electricity. Without electricity, neither my OT light will work, nor my ventilators will work, nor my defibrillators will work. I will not be able to take any ECGs. Everything collapses. My labs will collapse. So we also need power, whether it's generator sets, inverters, UPSs, we also need these. We have various, I'm sorry, I've put it on. We have various structures now. The armed forces, the Air Force recently showcased Bhishma, which is a cube with required equipment, some power systems, and medicines, which we can rapidly mobilize and move to any disaster area after a disaster has taken place. Bhishma, and this was also gifted to Ukraine when our Prime Minister went there recently. We also need people to manage the crowds. Security becomes a very big issue during any disaster. Emotions are running high. We need support from them also. And then we cannot have, predictability versus impact. Impact is what we look at. So disasters, we have to understand that disasters affect not only the population, but also the healthcare facilities. And the healthcare facilities need to be strengthened, need to be supported, and need to be prepared to be able to manage anything. With these words, I once again thank the organizers for inviting me. I'm really humbled to be in the presence of this galaxy of experts, and I would like to thank the other speakers on the panel for sharing their expertise. Thank you very much again.
Thank you, Dr. Rajiv Patni ji. Now it's a time for the audience to throw questions to the speakers. If anybody has any questions. No one has any questions? Huh? Yes, please. Introduce yourself and then you ask your question.
Sitting on the dais, we can correlate the disaster with COVID. So now you can correlate it. It is a kind of a biological disaster. And I was working in a government setup. The kind of emotional torture, physical torture we have underwent, that people, we were in the community, we were in the hospital. In my own hospital, I have worked for COVID in ICUs. So that building was a separate building. People avoiding or turning away from my path because I was working in COVID. So such kind of situations we face, and the most important thing which has been mentioned, when we are needed the most, the hospitals are collapsed. It was not about the numbers. We face this situation because we were not prepared, because the number was very high and the facilities was less. And that's what we have to emphasize. If we see the GDP spent on our healthcare system is just 1.5 to 2. At the same time, this proportion goes to 18% in the developed countries. So we need to focus on those things. Definitely, central government is working on disasters. I'm thankful for that. And we can learn from the recent experiences. Definitely, they are the people who has faced a lot of disasters in their past. And same thing I have seen, because I have experience of 19 to 20 years. Initially, there is a surge, like sir said, lot of josh initially, but during the later part, that josh goes away. Then we find a situation where we just need support. So such kind of situations actually happens and needs a lot of drills for such kind of disasters. That's it.
Thank you, Dr. Saab. Actually, I dealt with COVID from 20 to 22. I had been part of the central teams who monitored all the things, and I know how we dealt with it, not only from the health perspective, from other angles also, by imposing the lockdown, taking care of the points of entries at various places through various transportation mechanisms. Lot of challenges are there, but let me tell you that in disaster management at the global level, particularly the health and education sector has been given a priority. Out of the 7 targets which has been mentioned, I told you during the Sunday framework, the 4th target is focusing on reducing the damage and losses to critical infrastructure, particularly with priority on education and health. Because these are the 2 areas where we think the future generations, they're going to the education, and health is most important if you survive from the impact of any disaster situation. So these 2 areas have been tried to be addressed to the maximum possible extents, but still lot of gaps exist and persist, and we have to sustain our efforts for making them more resilient. And there are a lot of programs in Ministry of Health and Family Welfare. I've been dealing with even public health emergencies and trying to integrate that after the COVID-19 with disaster management. And we have come out with a 5-tier level approach which has been actually appreciated at the global level in global health security platforms too. So you can see that how we are trying to work out, and we are now working with the even not only disaster emergency operation centers, for public health emergency operation centers also there are programs now being implemented. And for the healthcare, it's already said for tertiary care particularly, there should be disaster resistant. And many such examples are there in the past where we lost those facilities. Even during COVID-19, we had to suffer because some of the hospitals ran short of power, some of the hospitals got fire, and many of the doctors, they also became casualties. So they are always there. All are human beings and we have to work together, and these are our priority actions. Thank you.
May I say something? Yeah, add to that. Thank you. Thank you for bringing this into focus, because the disasters that were the focus today is where hospitals collapse and crash. COVID or biological disasters that we talk about, this is where the hospitals are intact, and yet it's a catastrophe. It does happen. There's one thing that I want to put it out here on the table. We always hear that the government is not spending enough. Portion of GDP is not enough and everything. Global health security, which was just mentioned here, I have worked in this field, written extensively, and for Harvard also on this thing. There's something called the Global Health Security Index, which put US and UK on top and countries like Somalia, Ethiopia at the bottom. During COVID, Somalia fared much better than US and UK. Countries which spent 18%, 15%, 10% of their GDP fared very poorly when it came to handling the public health emergency. So it's not about money, it's about how we use the money. Kerala has better maternal mortality indicators, infant mortality indicators than USA. Kerala, it's a state within our own country. So it's not about how much money should be there, it is about how we use that money. That's more important. But thank you very much for bringing this into the focus.
Any more questions? Anybody else has any questions? Yeah, please. Srivastavji. Okay, you have to answer people asking questions. Okay, let the younger guy take up the question first.
Good afternoon, everyone on the panel. Thank you for the wonderful speech. So my question is, like, as sir identified that there is a certain type of limitations and gap existing in the medical sector regarding when a mass disaster happens. So my question is, like, we have the technology, we have like brilliant minds working in the field of research and scientific. So when a mass kind of a disaster happens, so why there is this, still there are major casualties happening. So what are this major limitations and gaps existing in this scientific structure? So I just have that question, that why we can't like detect it before, like we have the technology, we have every kind of resources, we have like every kind of resources to like know the people there that this is going to happen. So we can save more our resources than on medical facilities than saving the people there. So what is that biggest gap in the research and technology that we can't do that?
You want to answer?
Sometimes the last speaker gets lucky, because then all the questions are, that's the residual memory. Right. Thank you for the question. And it's a very important question, and this is something that we have been grappling with for the last thousands of years. Despite the best efforts of mankind, nature finds a way. Now, if I break your question into two parts, first is why can't we predict it enough? That's in the domain of my other panelists here, how you predict, how you become resilient. The second part of the question was, why do you have such major injuries? I can only be philosophical about it. You have injuries because of the force of nature. If you ride a motorcycle or a car, you know the moment it has crossed the speed of 20, you cannot control the outcomes after that. You hit a pedestrian even at a speed of 20, it will have a severe impact. Now, translate that into earthquake forces. What would it be? It's not just 20 kilometers per hour. The kind of force that it packs is enough to move mountains. So that's the nature of force which is impacting you. Tsunami, one big wave came and wiped away everything. Water has a lot of force. And I said, I'm going to be a little philosophical here. We have forgotten our roots, which is what was being mentioned here. Our traditional architecture was built through experience of thousands of years. But now we are going in for convenience. Japan has gone back to its traditional architecture. The walls are made of wood and soft materials. We need to look within and see what we can do. When the tsunami came, I have had the fortune of serving in Car Nicobar, which is a small island in the middle of nowhere. There's the Andaman Nicobar chain, but Car Nicobar sits in the center, away from any of the other islands. Fortunately, I was not on the island. I got posted out. There's an Air Force base there. I was in Jaipur. And when I saw the visuals, I cried. Because the house that I used to stay in, only one column of that house was there. This was the force of the wave that came in there. Surprisingly, the tribal people in these islands, with no radar, lidar, or any kind of predicting facilities, they had moved to higher ground, they had moved to inland areas the previous night. They survived. They are still using their traditional knowledge. They are not waiting for anything. They listen to the earth. They listen to the birds. They moved in. Minor injuries, but no major injuries or casualties amongst them. These are the tribals. So I wish we could reduce the impact, and that was what I was talking about, the hospital preparedness, the structural elements, non-structural elements, and functional elements. I hope it satisfies your query. Yeah.
Let me supplement what he said actually. We are highlighting actually stories where there is more sensitivity involved in terms of casualties, but that's not the complete part of the story. There is another perspective where we got the success rate. I can cite to several examples where we could reduce casualties from thousands of casualties which happened in Odisha cyclone on 29th October 1999. Around 13,000 people got killed. I still remember we started getting the success right from the Phylline cyclone in 2013 when the Uttarakhand disaster also took place. 1,000 casualties happened. But in Phylline cyclone, there was no death because of cyclone. There were few deaths because of flooding after the cyclone. But in the last years, when the Biparjoy cyclone happened in Gujarat, we could achieve our target of 0 casualty. And could save all the lives, not only humans, but even the animals and the wildlife too.
So Odisha has been
a
wonderful example.
Odisha has also done many good works. So many of the good examples are also there. But we are actually always focusing on what is going wrong and where we need to amend ourselves. So that's one reason. Now last, before we conclude, I think Professor Srivastava had something to say.
Good afternoon. I am Colonel Sanjay Srivastava, and I was live at Bhuj on 26 January 2001, and last week I visited Bhuj, same Anjar. What Group Captain Patni highlighted about the psychological trauma. I met my old friends, my regiment was there in Anjar, Surja Ben, and all. even after 23, 24 years have passed, they live in same trauma. And I tell you, when earthquake happened, my regiment was the only one, and we could save life. When I went to village this time, they all were crying. They all were crying not because I visited the village or something, because we were able to save many injured lives. That matters more. So what Professor Surprakash told you, many lives what we save is not highlighted. Today in India, the way risk profile is changing and the proactive action which is being taken, 99.5% life is being saved. Whether it is GLOF, whether it is landslide, whether it is trigger anything. We have early warning for everything, and early action is order of the day. Not only early action, we have the structural mitigation measures in place. Medical, we have just finished the national mainstreaming of disaster risk reduction, structural and psychological engineering in the national plan, and it's on the rollout. In fact, next week we'll be having a rollout on this. So there is a lot of proactive action on hospital front. Modular hospitals are being made. Go to Uttarakhand, even Panchayat has a kiosk and they are addressing the medical emergencies. So what he said, Global Health Index, if you see, the Kerala has HDI of 7.71. European countries don't have. So we have a lot of progress which is being made, and since we are a big country, vast country with 1.4 billion population, we have huge amount of work to go on. So that's the opportunity for people like you. And today you see the top man, the political mandate which disaster management has got. Even a small trigger, the PMO holds the meeting. That shows the importance what the disaster management today is. Thank you, sir.
Thank you, Srivastava. I think it's time. Sorry, because we are overriding the lunch session. Maybe somebody would be cutting. Who is hungry? So let's close this session. We can have a question and answers with the resource persons here. So I thank the organizing team for providing this opportunity to chair this session, and all the speakers of the session for sharing their rich knowledge and making us more wiser and experienced than before. So with these words, I thank each and every one of you for your patient listening and active discussions and questions. Thank you very much.
I would like to thank all the esteemed speakers for their valuable insights and perspectives on multiple hazard risk mitigation. Now I would like to welcome Mr. Bishwajit Sahu, Group Director of ResQore CDPRR and Playzone Media, to hand over the mementos to the dignitaries. Dr. Surya Prakash Sir, Professor and Head, Geometeorological Risk Management Division, NIDM. Dr. Sandeep Singh, Professor, Department of Earth Sciences, IIT Roorkee. Dr. P.K. Joshi, Professor, School of Environmental Sciences, Jawaharlal Nehru University. Shri V. Uday Kumar, DDG, National Informatics Center. Group Captain Dr. Rajiv Patni, Founder and Director, PRAR Consulting, specializing in health, healthcare and hospitals.
We invite you all to join for the lunch outside.
Now let's begin session 2, panel discussion, strengthening disaster resilience, advancing risk assessment, mitigation and community preparedness. Session chair and moderator, Shri V. Uday Kumar, DDG, National Informatics Center. Colonel Sanjay Srivastava, founder and chairman, Climate Resilient Observing Systems Promotion Council. Dr. Naresh Rana, assistant professor, Department of Geology, University of Delhi. Dr. Seema Valakrishnik, senior consultant, HAG, Emergency Medicine. Dr. Hari Narayan Tiwari, founder, FloodCon, Punch Solution and water management expert. I would request all of the speakers to please be on the podium. Shri V. Uday Kumar, Deputy Director General at NIC leads Geospatial Technology and Services, contributing to national disaster management, food processing, petroleum, chemical, pharmaceutical, and biotechnological sectors. With expertise in digital governance, he plays a key role in integrating technology for disaster resilience and infrastructure future planning across India. I request Sir to be here on the podium. Thank you.
Welcome back. Session after lunch is always a heavy session for everybody. Yeah. So let us start right away. We have very interesting panel. I am sure they will grab your attention and tell you about more about climate resilience and disaster risk mitigation. Now, I will introduce the first speaker, Professor Colonel Professor Sanjay Srivastava. He is chairman of Climate Resilience Observation System Promotion Council. He is a retired colonel from the Technical Combat Arm of the Indian Army. He is an expert in radar, remote sensing satellite, and communication technologies. He also serves as convener of the Lightning Resilience India campaign and is member of the National Panel of Experts on Lightning under National Disaster Management. Over to you, Sanjay ji.
Thank you so much. वहाँ से सर?
वहीं आपका मर्जी.
Johar, good afternoon. I really find what sir was telling, Uday sir, it's difficult to address the post-lunch session. So I'll request everybody, if you can just stand up, please. May I request to sit down, please? Now, how is the Josh?
No.
How is the Josh? And I must tell you, all those people who are not attending this lecture are the loser. Because what I am going to speak to you is most contemporary and most futuristic. And you can find yourself where you can fit in. Because today, India is on a journey as in Amrit Kal, we are the fastest developed economy, and by 2047, we are going to be a developed country. And I am sure before 2047. But I always put this but, provided there is no earthquake in North India. So GeoRisk is the most potent risk, and the students, researchers, professionals who are here, you got a lot to contribute. Gone are the days of policies, guidelines and advisories. It's early warning, early action, mitigation, societal awareness to adapt everything. So we are into building resilience, adaptation and sustainability with sectoral approach and citizen science approach. I am Sanjay Srivastava. I am from Air Defense Branch of Indian Army. For the last 18 years, I am working in the field of disaster management, right from the conception of NDMA to its foundation. Then I took premature and I am working in this field. I always believed that governance is a musical chair. You come there for 1.5 years to 2 years and you move out. No secretary stays beyond that. It is the academia, it is the practitioner where the knowledge is showcased. So you are the permanent factor. You are the person who is going to carry this knowledge forward. My organization, I am not the founder. It is Climate Resilient Observing System Promotion Council. All the observing systems of satellite, radar and ocean, we have the access to the server, we decipher the data. The founders are 14 people, they are part of the governing council. Dr. K.J. Ramesh, former DG IMD, currently RIMES. Dr. Mrityunjay Mahapatra, you must be familiar, and Director NRSC, and NDMA nominated members, they are part of the governing council. We are the organization, we are bridging the gap between IMD, ISRO, INCOIS, NDMA and the state. Whatever is conceived, we believe in making the same plan for a state, go to the community, implement it. And fortunately, unfortunately, I find this sector most non-competitive sector. How will this move forward? It's not happening with that. Yeah. So this is our organization. So we have the scientists, we have the bureaucrats. So the knowledge products, we take it to the state, to the community. Zero avoidable death. That's the policy of India conceived in 2009, but really practiced now. India's approach is preventive. Preventive approach is three-pronged. We are building resilience. We are onto adaptation, and we are onto sustainability. The efforts, programs which are there should be sustainable. So the policy and the fund, you will be happy to note that mitigation fund is 2,61,000 crore by 15 Finance Commission. Next year is going to be enhanced. So right from a zero mitigation to this level, this speaks commitment to the government and the decision makers. Early warning, there is not a single hazard for which early warning doesn't exist in India. We have the knowledge, but this needs to be upscaled. This needs to be transformed into action. National mitigation programs. There are 9 mitigation programs which were launched by NDMA till 4th February 2025. That speaks volume. In last 2 years, what has been done? Fortunately, all the GeoRisk programs, that is a national GLOF program, the national landslide risk mitigation program, a national program on earthquake. I have been co-author or as an expert on early warning, I have been part of it. So one has gone through the rigorous midnight fuel burning and working for it. So GLOF program is 150 crore in 4 Himalayan states. Our organization was the first one that post Chamoli, we could commission a GLOF early warning at NTPC's Tapovan project. Now we are assisting other states. We have the landslide risk mitigation program, 1,000 crore in 14 states, and national earthquake risk mitigation program in earthquake prone states. Landslide program, these are the states. Again, the emphasis is on the technology. You must be aware that GSI, which is the responsible early warning agency for this, has already come up with a early warning system through an app called Bhooskalan. You can download from App Store. Besides this, we have a tie-up with NASA. We superimpose our technical inputs, and wherever the gaps are, we fulfill that. Community awareness about the susceptible areas, the building construction technologies, the early warning indicators, risk indexes, risk movers. So all those things are in a gradual manner being implemented in these projects. These are the states where they are there, and budget as sub-allotment, I have shown it here. This presentation will be available to, I will request the organizers to make this presentation available to everybody so that they can get benefited. Earthquake featuring all the zone 4 and zone 5 states. Again, the stress is on building code, resilient infrastructure, and the common housing, common man's housing. So various designs have been made by the Ministry of Housing and Urban Affairs, and through BMTPC they are being implemented across the country. GLOF, these are the 4 states. You will be happy to note that in 2024, 28 expeditions were undertaken, 7,500 glacial lakes identified, and in the hydroelectric projects, 100 vulnerable areas were identified. And state-wise, program has been undertaken in a collective manner. Collective manner, it is not only the state disaster management authorities, it is the ISRO, IMD, foreign agencies, CDAC, everybody on board. Indian Army, Border Security Force, everybody together, this is being taken up. This year we have more plans, and someone who is adventurous, I would request, we have 2 interns working here, Lubna and Nikita. They are working on GLOF for Himachal. If you are interested, you are welcome. This is the action plan which is there. Now I'll come onto the early warning. The early warning in this country is something we are really proud of and to boast of. But internally we know more you detect, more is the challenge. So the complete detection system, you must have heard that when I came to Delhi in 2017, India had 17 Doppler weather radars. Today we have 62, and by next year we will be completing 81. So the doctrine of surveillance, complete detection will be there. The national program on earthquake, which is there, it's going to take time in spreading out the sensors. But yes, we have the basic early warning available. Delhi Metro, it has on-site early warning system. The moment there is an earthquake, this metro train will stop within 13 to 18 seconds. We have the NMDC building, we have the few secretariats, we have the Nagaland secretariat which we have designed. are earthquake resilient. Patel Bhavan in Patna, you can see they are on base isolation technology. So we are on to basically action, mitigation. You need to adopt earthquake resilient construction technologies. At the same time, these early warnings are very important. This is to keep you alerted, because human tendency is, mujhe to ye hoga hi nahi. So these early warnings are very important. California, US, if you go, even a 4 shake, on Richter scale is publicized. In Japan, it is 5. Why? Because the community habit has to be built up. How will you respond to hazard like earthquake, which will be sudden, and how will you again reassemble to do your work? So Japan resilience time is now 10 minutes. We are yet to develop any such parameters. So complete early warning. Along with early warning, you should have early action plan. We have made the SOPs. It's like something like GRAP in Delhi. Similarly, with each hazard, such SOPs are made, and huge task lies ahead in educating the community what to do when the early warning comes. This is just importance of tsunami, which I wanted to play this video and show you. Sound. IT man.
It remains one of the deadliest disasters in recent history. Many of these deaths could have been avoided if people had catastrophe. They would have had time.
Can somebody help me with the sound?
Ocean's early warning and mitigation system. This international early warning mechanism uses
This is a video which shows that in tsunami 2004, 2.3 lakh people died in 13 countries. But post establishment of the tsunami early warning, we have achieved zero resilience. So there is zero death. Sorry, not resilience. So the early warning is very important in saving life. It is not only the early warning which is important, it is the community behavior to the early warning. Because community must respond to the early warning. Now coming on to the SDGs, 10 of the 17 SDGs are affected by early warning. This is India's hazard profile and global risk report. We stand at number 2. India tops the list of most exposed population because of being the most populated country living in the vulnerable areas. So we have done the risk mapping. We have done the vulnerability mapping of people, because it is the type of people, the type of socio-economic dimensions which are there, the type of housing and the type of livelihood they have. So these all have been done, and we are on to implementation of the complete aspect of early warning India. It is in the line of SFDRR, Sendai framework. Again, I have a video, but I doubt it will not run, because Sendai framework, the aspects have to be understood. We have been able to reduce the death of people, minimize the death of people, but the damage to the economic asset, that is our target. So I'm moving forward since it's not moving. So multi-hazard early warning system in India is being implemented now. There are many states who have done it, like Orissa, Karnataka who have done it, Gujarat has done it. So the complete early warning system where risk knowledge, dissemination, response and monitoring all are part of it, and it's being implemented. These are from 4 corners coming. The risk knowledge is coming from UNDRR, The weather part and the early warning in India is the mandated agency is India Met Department. And the response is coming from in India through NDRF and SDRF, Civil Defense, and the dissemination is taking place through communication. You will be happy to note that DDG in the Ministry of Telecommunication is moving now to MHA for complete dissemination. So that's a change in the governance. So these are the Indian parallels which you should know if you are in a sector where to work. And this is the budget commitment which is there. And these are the facilities through NDEM, Early Warning National Disaster Emergency Management Database of ISRO. This is the protocol and initiatives. This is the climate adaptation part. You see, one part is the mitigation, second is the adaptation. So we have the solar energy mission, we have the solid waste management, we have sustainable agriculture. All these things I am showing in slide. Since I have just 10 minutes, I have already exceeded the time. We have come up with a dissemination protocol, and you will be happy to note that cell broadcast technology was commissioned last year. And in Kumbh 2025, this is in practice. In layman's language, I can only tell you that once we issue the early warning through cell broadcast technology, every media, whether it is mobile, TV, radio, will be captured, and only emergency message will be free. So there is a very important role of data-driven service. We are working on a national disaster data platform, not data center, data platform, where we are creating specialized menus and menus on demand. We have all the data of IMD, ISRO disasters there. Whatever is your research requirement, you put it there, you will get, it's an AI-based platform, so complete DM operation will be regulated by this. And an integration between early warning agency and community through various means is being done. We have a software. This is an opportunity for startups. We incubate them, we facilitate them. Available technologies for multi-hazard early warning. And this is a picture, lovely picture from Betla Forest, Jharkhand, where tigers were spotted. The multi-hazard early warning way forward, we have got the API. You can take the API if you are a researcher. You can check the hazard, its implications, trigger location-based alert, computer-aided dispatch, real-time monitoring, evaluation. And if you go on the NRSC and IMD website, you will find a community engagement. Whatever is your observation and whatever is the forecast, you please send the pictures, send your observations. More the feedback, better is the outcome. This is the IMD Lightning Complete Forecast Network, what we have now. This is a Sachet. All alerts have been integrated on one platform, Sachet. And all response 112. 112 single emergency number, well, all emergencies, whether you need medical, police, fire, gas leak, anything. This I find is the biggest achievement of my life so far. In the Nirbhaya case, when it took place in 2009, I wrote, and fortunately the responsibility came to me. And this is pan-India done now. So there are a lot of enablers. We have monsoon meter, carbon meter, sustainability, real-time location, point alerts. Lightning is one. Again, early warning to setting up the national program, we have done it. And this is where we end. Public awareness is the last. This you must know. This is where the fund lies, where to bid. And the future way forward is collaboration and research, knowledge hub for technology transfer, startups, know the policies and funding windows, citizen science, community adaptation, and lastly, last but not the least, whatever you do should be sustainable and adaptable by others. Not only you, think about others, because it is not only human grid. We are not only for saving life, we are for saving the ecosystem. So a comprehensive ecosystem-based approach is required. Thank you so much, sir, for this opportunity. Thank you to the organizers for inviting me and giving this opportunity. Thank you.
Thank you, sir, for giving an overview of activities which under NDMA you people are doing. We are, as NIC, we are also part of that ecosystem. So now I request Dr. Naresh Rana, Assistant Professor, Department of Geology, University of Delhi, to give his lecture. Dr. Rana, his research interests include active tectonics, geomorphology, geohazards, and Himalayan tectonics. Before joining the University of Delhi, he served as Assistant Professor in HNB Gharwal University as a scientist in National Center for Seismology, Ministry of Earth Sciences. Dr. Rana earned his PhD and MSc from HNB Gharwal University, focusing his doctoral research on neotectonic investigations in Alaknanda Valley, Central Himalaya. Thank you, sir.
Thank you, sir. Thank you.
Kindly adhere to the time.
Okay, sir. I will try my best. You can stop me when I will be exceeding. So, thank you, Colonel Srivastava, for setting the stage. Now, I think people are not sleeping. And I'm happy that some of you are also working on GLOF, right? So, are you from geology background, geography background, GIS background, which background? Geography and GIS. So, I have some audience to listen me, right? Okay, so I'm going to talk about flash floods, so that there is some mismatch, little bit mismatch between my topic which is printed in this program and this one. So I'm talking about flash flood assessment. I'm also talking about some geological approaches which you must know while going for any kind of risk assessment. So we all know that during the last 2 decades at least, there have been many events, many incidences of these flash floods, particularly in western Himalaya, in Garhwal region, and also in Sikkim, right, recently. And this was the first image on the left side was from the 2013 Alaknanda flash flood, or you can say Mandakini flash flood. The second one is the recent Dhauliganga flash floods. So in the first one, around 10,000 people were killed. In the second one, around 200 people were killed, and a large project was devastated. So overall, we can observe that during this period, the intensity and the magnitude of these flash flood is increasing, right? And these flash floods are mostly associated with the glacial hazards. And you know that because of climate change, the glaciers are receding, they are melting very fast, and with the same velocity, with the same rate, these events are also increasing. So because of this, and now in addition to that, we are also experiencing that a lot of people are now inhabiting in these small valleys. Lot of constructions is going on, lot of infrastructure development is also going on in these valleys. So overall, the risk of flash flood is also increasing in these locations. So there is a need for a risk management, there is a need for a hazard assessment, risk reduction. And I think in the morning session, Professor Joshi was telling about remote sensing and many models about flash floods, and also I think you people know about many hydrological models that are used in GLOF, flash flood modeling. So the only limitation with these model is that you have to have some data. You have to have some idea about the topography. You need some data which will give you the overall discharge, how big will be the lake, right? And this is where we have limitations. If you will see the data, if you will be actually working on these problems, then you will find you don't have any data. You don't have any data of the river discharge, and if there is any data, you don't have access to get that data. And in addition to that, because that data will be just for a very small duration, right? And if you will see the last 3 events which I am talking about, all these 3 events have different mechanism, right? They all have created flash floods, but the first flash flood was because of rainfall plus lake outburst. The second one was not because of rainfall, not because of any lake burst, but it was just because of a avalanche. In the third one, it was purely based on a lake outburst, the Lotak. right? So there are different mechanisms, and because of these different mechanisms, there is always uncertainties with these hydrological models. And because of that, that's why I'm talking about that if you have uncertainties in these models, so in order to bypass that uncertainties, in order to give some comprehensive model of the risk, you need to go for some geological approaches. So I'll be talking about these geological approaches. So for example, in this case, the ultimate aim, the final goal of any risk assessment is to develop this hazard matrix. And you can see that this is just a hypothetical matrix I have made. So there are different colors, and these colors show different level of hazard. So this matrix is actually the hazard, the frequency, how often these hazards occur and how severe these hazards are, right? So this is the thing you need to make any risk map. So you can see that there are numbers 1, 2, 3, 4, 5. So these numbers are not something that you will get automatically from any software, any other kind of mechanism. You have to go to field. You have to understand the socio-economic pattern of that area. You have to understand what are the actual hazards available in that area, and how these different factors like climate, landscape, earth surface processes, how these factors interact with each other to create any disaster, any flash flood events. So this kind of exercise is required, and you need lot of data for this. You need lot of, because you have to create the probability of different level of hazards. For that, you need to go beyond the human history. You need to go beyond the data of 40 years, 50 years. You need to go beyond the hydrological data that your departments are collecting from different rivers. You have to go beyond that. So this is just an example that we have many kind of hazards in our high mountain regions. The first one was an avalanche. The second one was an old case of lake. So all these kind of events keeps on happening in Himalaya because it's a dynamic system. So we need to have idea about all these events, that what are the possibilities, and in addition to that, during the last 3-4 events, we have gone to the field, we have investigated the area, and we found one interesting thing that is called the debris, right? So if you will go in any glacial valley, you will see that there is enormous amount of debris. Enormous amount of that debris was actually left there by some glacial advance of the past, and this debris also plays significant role in enhancing the magnitude of flash floods. So whenever we are talking about flash floods, we just try to measure the size of a lake, and we put that data in a hydrological model, and then we simulate the model. We never talk about this sediment, because this sediment has the power to amplify the magnitude of flash flood to many order. In addition to that, if you will see that this is one study from Alaknanda Valley. So all these flash floods beyond our history, we can also go for these. We can do some sedimentological investigation in the valley. We can find some sedimentological evidences of past flash flood in the valley, and these past flash floods are, they have this kind of characteristic sediment. They have a coarser sediment, and then that coarser sediment is capped by very fine sediments. So by these methods, we try to go into the history, in the past geological history. And okay, sir, thank you. So we try to go into the past history, and we try to collect the data of the past flash floods from the valley. So finally, we need to make a relationship between these magnitude and the frequency of these flash floods for creating that hazard matrix. So this is one case we have tried to do from the Gangotri area, and in this case we had no data about the past flash flood from that valley, because this valley is also located in a similar valley, like we have the Mandakini Valley, or you can say the Dholiganga Valley. So similar kind of hazards can occur in this valley. So you can also take the data from the different valleys to interpret the hazards in your area of interest. So here we try to take the discharge from the 2013 flash flood. We try to take the discharge from the 2021 flash floods, and we simulated models, 1D model, and then we came up with this simple hazard map of Gangotri Valley. So overall, this is my last slide. So I just wanted to say that using this approach, including geological data into your analysis, you are going to get a more comprehensive risk assessment of any area. So you just need to go for some field work, you just need to investigate the sedimentological and geomorphological evidences of past flash floods. You have to do some analysis to understand the interaction between earth surface process, climate, and the hazards. And then you can come up, you can put this data in any software, in any model, and then you can come up with this kind of final output that's called the hazard risk map, right? So this is all I wanted to say. Thank you very much for listening me.
Thank you, sir, for adhering to timing. Great exposition on hazard matrix. Now I request Madam Seema Balkrishnan Vasnik, Senior Consultant, Dr. Ram Manohar Lohia Hospital, New Delhi.
Good afternoon, everyone.
Doctor, she specializes in emergency medicine, has extensive expertise in critical care, intensive care medicine, mechanical ventilation, sepsis management. Dr. Vasnik has contributed to numerous publications in that field. Thank you. Ma'am.
Good afternoon, everyone. Thank you, ResQore, for inviting me as a speaker today. I would like to. On desktop. Yes.
Which one is your?
So I hope everyone is in Josh right now, and it's nothing like I want to offend anyone, but I would like to ask that how many of us are trained in first aid, or we have attended any first aid sessions prior to? So some of the doctors, medical background and geological background, interns, and so the community participation is the most important thing in disaster management, and that is what Dr. RML Hospital is trying to do, but we want to do this on a larger scale. Like Dr. RML Hospital is known for training police control, police personnel in first aid, firefighters who are posted at the Indira Gandhi International Airport, then providing first aid to laymen and people applying for commercial driving licenses. So they are actually the first responders. The Transport Minister has recently also announced that about the Good Samaritan Act, that whosoever brings a patient to the hospital will not be harassed for bringing the patient, and he will not be stopped by, and he will not be asked for any financial assistance, and he will be awarded 25,000 rupees if he brings any patient from outside the hospital to the hospital or a definitive care center. So it is very important that the community should participate in disaster management process. So I'm also very much impressed with my previous speakers, Colonel Sanjay and other learned speakers on building codes and also the multi-hazard warning systems, and also about the remote sensing in earthquakes, landslides and everything. And I would like to highlight certain things that Dr. RML Hospital is known for disaster preparedness because it is in the heart of the city, just adjacent to the Parliament House. And throughout the year, we are already preparing ourselves for mass casualties. Right, recently we had 26 January event where more than 77,000 people, not only from India, but also from overseas attended it. So we are prepared for the mass casualties, and then we have got liaison with the pre-hospital ambulances, that are the CATS ambulances, and the neighboring states like Uttar Pradesh, Haryana, and also the private hospitals like Medanta, Apollo, Fortis hospitals. All of them have their advanced cardiac life support ambulances. So around about 50-60 ambulances, and along with RML hospital itself having about 10 ambulances, all of them participate in the Republic Day pre-hospital preparedness, along with RML providing them with the emergency rescue teams, the doctors, nurses, paramedics, and at the site, at the venue itself. So RML hospital is always prepared for mass casualties, and well, in the 2019 epidemics, RML hospital had some novel approach towards disaster management, and it was kind of a biological disaster, and then we had some Y connectors because there was shortage of oxygen supply to the patients. So these Y connectors were inserted at the oxygen port. That way, instead of one victim, two patients were getting oxygenation. So that is how we increased the oxygen supply to our patients. And I was in charge of the procurement that time, and we were from multiple sources. We were procuring things for like we wanted non-touch thermometers and also sanitizers and PPE kits. So we were getting it from multiple sources, and there was no problem about the budgetary constraint, or there were no bottlenecks. That is why we could succeed. And also there was a lot of innovative approach in managing patients, like COVID patients were suffering from cytokine storm, and we used certain novel approaches like cytosop therapies, which were very expensive, but some patients had definite advantage and they came out of the crisis situation. Also, we had procured number of medicines which we never heard of, like antiviral medicines like remdesivir and favipiravir, and then vaccines were also arranged for everyone, and all the staff were vaccinated, and even people outside the hospital were vaccinated against COVID. So I would like to speak about the emergency medical response team. So whenever there is a disaster, we have to respond to the disaster, and then there is recovery, mitigation, and preparation. So whenever there is a disaster, first step is there should be mass evacuation. It could be a building collapse, so mass evacuation and extrication should be there, or if there is a fire hazard, the fire first aid fighters will go and rescue the victim, and the emergency responders the first aid responders will then respond and attend to the patients. What happened in September 9/11, many emergency paramedics, they rushed to the rescue, and because of that, their life was not spared, and they instantaneously died at the spot. So idea is that the first responder has to first ensure scene safety, and only after that he can provide first aid to the victims. So first and foremost, the scene safety has to be ensured, and whenever there is a mass casualty, then we have to apply the simple triage and rapid treatment protocol. So if there are multiple people on the ground and it is difficult to understand, so I just have to announce that how many people, if you are hearing me, please come and walk towards me. So walking people that means they are conscious, they are fine, and they are walking towards you. That means they are labeled as green patients. Then the second patients are how many people are listening to my voice, and if they respond that yes, I am listening to your voice, that means they are yellow, that means they are conscious and they are listening to you. And the third one are lying still, they are the black ones. You have to quickly go and assess them. If they don't have any respiration, then you try to open their mouth and see if they are responding, and if they are unconscious, and they don't have any pulsation, that means they are labeled as black. And the yellow ones, if they are conscious and their pulsation and capillary refill is fine, then they are the yellow ones. But if the capillary refill time is prolonged, then they are bleeding from somewhere and they become red, and we have to first and foremost control their bleeding.
3 minutes more.
Okay. So whenever there is mass casualty, the approach of managing is on the field, and on the field, once you assess which category this patient is, you rapidly try to stabilize them, and if the hospital is nearby, then you have to scoop and run. And if the hospital is at distance, then you have to first stabilize then and there itself, and then you can transfer the patient. First 20 platinum minutes are the most important minutes while attending to such mass casualties like controlling of bleeding, or if there is airway obstruction, then you have to relieve the airway obstruction, and then you can transfer the patient in the first golden hour to the appropriate healthcare facility. So the advanced trauma life support protocol came into existence in Nebraska when a orthopedic surgeon, he met with an air accident, and his wife died instantaneously, and he and his 3 children were critically injured, and they were brought to a primary health center. And there it was found that the way he was managed and the outcome of his treatment would have been better if there was some protocols, if the treatment was protocolized. So that is why the protocol system was devised, that is the ATLS, Advanced Trauma Life Support Primary Survey of airway, breathing, circulation, disability and exposure of the patient. So you assess the patient, and simultaneously, if he requires any emergency management, you manage the patients. And when the patients come to the hospital, the incident commander is the medical superintendent of the RML hospital, and already there is a disaster plan which is available in the hospital. So according to the this disaster action plan which is available in the hospital, which has got several members, all the head of the departments are the members of the disaster action plan, and the chairperson is the medical superintendent. The head of the Department of Emergency Medicine is the member secretary. So in the absence of medical superintendent during emergency hours, the emergency control room officer becomes the incident commander. So he is responsible for communication, for security, for secondary triage of patients coming from the field, and he is responsible for the closed loop communication with the field where the patients are being attended, and he is also responsible for the surge capacity of the hospital and arranging the mass casualty, arranging them beds and emergency equipments, and that is why he has to liaise with the store and purchase departments also, at the same time open the disaster cupboards in the emergency department, and whatever arrangements have been made, he has to mobilize all those arrangements, including the manpower. So he is the one who is going to activate the orange code. So we have got 284 beds in the emergency care service department, and we have got about 78 beds in the trauma center. So RML hospital is equipped with level 1 trauma center, and we have got all the specialties, neurosurgical and orthopedic specialties, the surgical specialties, and all the super specialties are available in RML hospital. And there is also a super specialty block coming up where we will have a helipad services for transporting patients also and for organ transplant purposes also. So it is a level 1 facility available, and we are also training manpower to manage disaster. So we are training about 30 pre-hospital trauma technicians everywhere, and in other government hospitals like Lady Hardinge Medical College and Safdarjung Hospital also, 30 each they are training. So total of about 90 pre-hospital trauma technician trainers are there, trained in every hospital. So the idea of training them is that there is a golden quadrangle between Delhi, Bombay, Kolkata and Chennai. So the government of India has plans of placing these ambulances 50 kilometers apart, where these pre-hospital trauma technicians will be placed, and they will be attending to any kinds of emergencies, like maybe it could be trauma, or it could be acute myocardial infarction or stroke. So these patients will be stabilized by the pre-hospital trauma technicians, and they will transferred to the nearest trauma center, because the trauma centers will be about 100 kilometers apart on the golden quadrangle. So that is how the government plans to respond, and already Colonel Sanjay has said that we are having a common number, like America has 911, similarly India has got 112. So whenever you see any disaster anywhere, you just have to dial 112 and everybody will come to your rescue. So that is how it works. Whenever there is any pre-hospital emergency, you have to just dial 112. So we can create extra disaster beds this way, and if we require extra, if we require extra beds, then the OPD will be opened. Then after that, the old emergency block, then the new building, then the old building. So this way, it is a process of continuation that because RML hospital was established in the year 1932 under the British rule. But now after 95 years, it has improved, and it has improved more than 15 folds, and now we have got 1,500 bedded hospital, and even we have the surge capacity as well. So that is how we can manage multiple mass casualties whenever there is a disaster. So basically, RML hospital is also a nodal center for biological disaster, and at gate number 5 we have got a decontamination facility, and there will be a separate pathway, because there are multiple disasters happening, and multiple hazards can happen at the same time. So, and there can be some patients who are non-CBRNE, and some patients can be CBRNE. So during the G20 summit preparedness, we had a separate pathway for patients who were exposed to CBRNE, and a separate pathway at gate number 5 for patients who were non-CBRNE. The CBRNE patients would be attended at the disaster ward, and the non-CBRNA patients would be attended in the ECS building. So we have got a good blood bank which has this capacity of 4,500 units. As you know, that trauma patients can require massive blood transfusion if they are bleeding seriously. So in the first golden hour, if we are able to manage them with adequate blood, then we can save their lives. And we have to do maximum good to maximum number of people during trauma. So trauma is a chaotic situation, and RML hospital has addressed to various mass casualties, right from the Khandar hijack, where several casualties had come, although they were in a stable condition, and they just came for medical examination, about 200 travelers, and around at 9 o'clock in the year 1999. So we have seen bomb blasts, series of bomb blasts have occurring in the year, I think 2008 at Barakhamba Road, Connaught Place, and the Central Park, and the east of Kailash, and the whole night RML hospital was running emergency, and there was overcrowding of the media personals which was being managed, and there were visitors coming, and there was somebody who was maintaining the records, and they were visualizing the where was their, how was the condition of their relatives, near and dear ones. And I was the anesthesiologist that time attending to these patients, and I was called on the second batch, and then I entered the operation theater, and there were multiple splinters inside young people's abdominal cavity which were taken out, and then there was post-op management and rehabilitation. And whenever there is a incidence of trauma, we have to manage the post-traumatic stress disorders also. So RML hospital, apart from training the pre-hospital trauma technicians, we have trained trauma nurse coordinators also. So whenever there is a trauma patient, these trauma nurse coordinators, they are assigned, say, 5 patients. So this trauma nurse coordinator will be responsible entirely for the treatment of that patient, by like coordinating with the multidisciplinary teams, coordinating with the operation theaters, then deciding upon their discharges, and then after that attending to their follow-ups, their problems, their psychological problems, and addressing to their physical problems, their physical rehabilitation. So in entirety, the trauma nurse coordinators are trained to manage the trauma victims. So before that, lot of things were spoken about the building resilience and warning systems and everything. So one most important thing is that after any disaster, resilience is the most important thing. So how we can help the victims of the trauma, or the community as well as the doctors, to come out to withstand the challenges which are foreseen and unforeseen challenges, and how we can, how they can adapt to those challenges, and how they can recover from these challenges is the most important thing. And for that, we have to have disaster preparedness and disaster prevention. That is the most important thing. What happened in COVID-19? Many of the patients were discharged at the oxygen saturation of 80% with oxygen cylinders, and they were mentally disturbed and they were depressed. So RML hospital has arranged telephonic counseling, psychological counseling for those patients. And those patients, they contacted me that how can we improve our oxygenation? I am a lawyer at High Court. Will I be able to climb stairs? Will I become normal? Will I be off oxygen, or will I remain on the long-term oxygen therapy? I arranged an online yoga instructor for them for their breathing exercises. They learned breathing techniques, and now that lawyer is without oxygen and she is fully practicing. Then we have to give them nutritional support and so many things. So you have to employ several things and to address the post-traumatic stress disorders. And also we have to have a social resilience post-disaster. The children who are attending to school, we need to see that the infrastructure is recreated if that infrastructure is damaged. So we have to have resilience in all aspects, mental, physical, as well as the social resilience. Thank you very much.
Thank you. Now I request Sri Hansraj College, founder FloodCon and NDT solution for the management system. Dr. Hansraj College is the founder of founding partner and managing director of Ratcon Consultants LLP, a firm specializing in water resource engineering and flood management. He holds a PhD in resource development from IIT Roorkee, where his research focused on river engineering and turbulence hydraulics. Dr. Tiwari has authored over 40 research publications in the areas such as water resource development, piano keywares, river engineering, and turbulence studies. So, yeah.
Thank you.
Please head here to.
Thank you very much to inviting me in this particular conference, where I'm just giving a brief of prospects of GLOF, because GLOF we have discussed that what it is when there are glacial lakes, which is situated either in Himalayan region or northeast region in India. So there are multiple prospects that in terms of opportunity and what we are lacking. So I am discussing in very brief. So you can understand that what are the problems we are getting into. Like these are two images. One is from the Uttarakhand disasters, and one is from the recent 2023 disaster, which has happened above the Teesta dam. And the dam's failures, there are multiple casualties are there. So if we are going that how many glacial lakes in Himalayas, these are some statistics only. Like there are 28,043. This is the statistics from NRSC only. So these are the numbers which is already available within a public domain, that we have to look into that if there are failures, because we just felt a 1 or 2 failures. So what will happen? And then what the government did that there are multiple studies by the NRSC itself. But the thing is that if we are doing for a simple glacial lake burst, so what we have to do, either we have to wait for the GLOF, otherwise we have to analyze some with some computers models. So those are the technical capabilities that we are generating, so that we can make a library-based approach. If some things fail, then what will happen, and how we can react on that. So that is the process, and with that process, there are some studies which has been already carried out and which is going on. But in last 3 to 4 years, there are only 5 to 10 glacier lakes which has been studied in details, and there are some maps in terms of the areas which is vulnerable to that particular GLOF area. Within that area, it has been prepared. So you understand that if suppose I'm saying that if the 5 to 10 GLOF has been discussed and prepared in last 5 years, so the numbers are 28,000. So the first question is that whether our institutional capacity to do that kind of work or not. Because if one GLOF assessment requires 1 year to do, so for a 28,000 we require 28,000 if one institution is doing like that. So we essentially require the capacity building, because there is nothing else that can do, and we require more people to come into this field because there is an opportunity. So that we feel, because as a startup we are working in a modeling or other parts, as sir has already mentioned that there are some limitations. But within that limitations, we have to work, we have to also include when the glacial lake flood is happening, the important part is that our flow is not Newtonian flow. So we have to consider that it as a non-Newtonian. That means with the sediment. So that flow we have to consider within the model, and now the computers is having capacity to create those type of scenarios. And with those scenarios, we are able to succeed in our planning. And obviously, when I'm talking only about the GLOF as a disaster, it is having a less risk because we have already identified those problems. Because earthquake is having a more uncertainty. There is a certainty, but of course we have to also plan. Otherwise, the casualty what happened in 2023, apart from the early warning system, because Teesta is having early warning system, but at the time it was not triggered. So there is a problem in every system. So we have to first prepare for those. So these are some NRSC maps which are prepared for some kind of lakes. Already I think 5 to 7 studies completed, and it is in a public domain also. So you can also leak, and there is a simple process because there is a volume of water. If it is getting break either by any process, either by earthquake, either by landslides, because the last GLOF event which we are discussing 2023, but recently there is a one research. They said that that is not a GLOF event. It is a Himalayan tsunami. So they have mentioned that name in 2025 in a Nature. So they say that because of landslide, there is a like that lake break. There is nothing, only a single cloud. There is a increase in rains only. That is not the cause. So they have named it as a Himalayan tsunami. So that is a new name. And there is a simple process when we are having some kind of scenario. So we can analyze those scenario for particular lakes, and the key areas can be identified whether there is a key development can be done or not. There may be some kind of zoning will be there in the downstream affected area, possible affected area. So that can be done, and I think this will not run because there is no internet. You can go that. We have done some kind of exercise over that because as a practitioner we have to do some works for the different kind of reservoirs. If that fails, so what will happen in and how we can prepare in a 3D dimension if that is available with the decision maker, so they can tag that location. Okay, that locations may be affected by those particular event. So if the event 1 is happening, so this kind of approach is required. If the event 2 will happen, so that will happen. So that can library based approach will be very much helpful. And there are like certain things which we have to obviously integrate because we all need kind of softwares or IT supports or type of applications. So we are also into the IT support services where we are just trying to integrate that particular services to the solutions, to the customers also, and if it is required for the government institutions, we are into participating into the same. So I'm just, I have some suggestive remarks over there. The planning and regulations is needed, and the second part what we are discussing from the morning, that is the public awareness, because we are also trying to live in the riverbed, and when the river water is coming, we are saying that it is a flood or GLOF anything. So it's also our individual problem. And the mapping what we are discussing about that the case-based study can be done for all the GLOF based on the priorities, because 5 to 10 done by already ISRO and NRSC as a case study. So as a practitioner we can do, and climate resilient infrastructure what we are discussing like dams and other, where the other facilities can be like that, it can sustain the disaster. And the last floodplain management with a detailed implementable GLOF policy, like if there is a policy, the people are binded to do that. So thank you very much for inviting me.
Oh, thank you. You have heard about the plans of Government of India and NDMA, what they are doing about disaster management. Humongous efforts and a lot of initiatives are being carried out across. And you have also heard Madam Vasnik telling about what kind of a emergency management they are doing for health. And also from Dr. Naresh and Dr. Harnarayan Tiwari on their areas of expertise. I thank everybody. If you have any questions, you can just, you are open. Okay, if there are no questions, we can close this session. Thank you.
I would like to thank all the esteemed speakers for their valuable insights and perspectives on strengthening disaster resilience in India. Now I would like to call upon Mr. Rakesh Jha, Group CEO, ResQore, CDPRR and Playzone Media Entertainment to hand over the mementos to the dignitaries. Shri V. Uday Kumar, TDG National Informatics Center. Colonel Sanjay Srivastava, founder and chairman, Climate Resilient Observing Systems Promotion Council. Dr. Naresh Rana, assistant professor, Department of Geology, University of Delhi. Dr. Seema, senior consultant, HAG. Dr. Hari Narayan Tiwari, founder, Floodcon Solutions Private Limited. I request all the esteemed dignitaries to be here for a group photograph.
एक बार रुक जाओ, अगर फाइल कॉपी करने दो, वरना मेरे को भारी पड़ेगा फिर। ये उठ के नहीं आ पाएंगे यहाँ पे यार। अरे तो वो उस पर भी तो चाहिए ना फिर, डेस्कटॉप पे।
डेस्कटॉप पर डायरेक्ट थोड़े हम आप कॉपी करें।
जी ये सॉल्यूशन।
Session Chair and Moderator, Dr. Aniruddha Roy, Chief Technology Officer of Genesis International. Ms. Rakhi Kashyap, Associate Initiative Lead, Disaster Risk Reduction and Climate Change, Civic Data Lab. Shri Vimanyu Sharma, Manager, Pre-Sales at ISRI India. Dr. Harinarayan Tiwari, Founder, Floodcon Solutions LLP. Dr. Aniruddha Roy is the Chief Technology Officer at Genesis International Corporation Limited, bringing over 25 years of experience in the business management, technology services, system integration and solution development. Before joining Genesis, he served as a Vice President, Strategic Business at Navayuga Engineering Company Limited. An alumnus of IIT Roorkee, Dr. Roy holds a doctorate in Environmental Sciences and Engineering from the Indian School of Mines, Dhanbad. I request Sir to hold the mic.
Thank you so much. Am I audible? Am I audible now? Yeah, okay, excellent. Good evening. I think this is the fag end, and we do have four speakers, right? One more speaker?
Yes.
Okay.
Our last speaker is Shri Gaurav Ashudani, Head Business Growth and Strategy, Tech Eagle Innovations Private Limited.
Yeah, welcome, Gaurav. Yeah, thanks. So just before starting this event, I think this session, I just wanted to know one thing. How many of you are students? Okay, understood. So one request, if you don't mind, if you all come in the center, that will be better. We can just talk in the middle itself. So the time which is allocated to each of the speaker is 10 minutes. We are behind 35 minutes now, but that's okay. So as the customary is that I need to give an introductory talk, which I felt I should do it after all the panelists in this session, they complete the talk, right? So may I invite Ms. Rakhi Kashyap, Associate Initiative Lead for Disaster Risk Reduction and Climate Change at Civic Data Lab. Ma'am, please. So she serves as an Associate Initiative Lead for Disaster Risk Reduction and Climate Change at Civic Data Lab. In this role, she is instrumental in shaping and driving initiatives that leverage data, technology, design, and social science to enhance civic engagement and resilience against climate-related challenges. One of her notable contributions include involvement in the development of the intelligent data solution for disaster risk reduction. This initiative focuses on integrating diverse data set to provide insights into flood hazards, exposure, and vulnerabilities, thereby aiding government and communities in better flood preparedness and management. Ma'am, 10 minutes is okay?
Less than 10 minutes is fine.
Yeah. Because I sorry for the interruption, I feel this is not an educative session, it is just an awareness and sensitization. As long as we all know what is that the core message is, I think that should be fine. Then we are always, our phone numbers, our email IDs are always there. We can always collaborate. Okay? Ma'am, please.
Okay. Am I audible? And I'll not keep this as an information overload. I'm a climate change and DRR professional for the last 13 years. And during this session, I would like to encourage a lot of my female counterparts to be really, be very proactive, because we really get to see less of a women in disasters and climate. My little background, I've started working since Kosi floods, then Nepal earthquake, then Sikkim, and also then shifting my trajectory into climate action. What has importantly, what I'm going to talk today is a strategic framework and the trajectory change that have actually shifted in the last 13 years. And that is perhaps how even India is moving in terms of disaster responses and climate action. And that's what I believe, instead of a lot of information overload, just bringing an understanding where is India heading. We also had an opportunity at a Paris Summit, AI, wherein we showcased our work in how are we moving with different strategic framework that we are discussing within the government, national till state and the local governments, bodies, and how this strategic decision-making is helping shift our approaches and entire practices in DRR. That's the overall understanding with a little brief introduction to what we are doing, perhaps if that helps. So like why, so our responses presently, like the project that I'm leading is majorly into hydrometeorological disasters. Why? Because the statistics are very clear. Importantly, it pertains and like, into whether it's the number of reported cases, whether those are the casualty, even one casualty is a big casualty for any of the family when they, faces any of the situations, people affected or economic damages. What importantly in case of India and to contextualize flood better, we need to understand like, the floodplains that flows across the country, how it flows, what it flows, but in exact number, what impacts does it bring. The reason like I state some numbers because like if we know what is enormous damages any of the event brings us, we are also, in aspect of responsibility, are very clear where our intervention should look like. So we actually work in, leveraging a lot of climate data, but I'm not going to talk about what data does. What I'm going to talk about is how do we create a data ecosystems? How do we start from the basis? What do we understand when it comes to climate data ecosystem? And what kind of a strategic framework it should actually enhance in understanding, even if there is a data lying on your phone, how do you make use of it? It's a very comprehensive and a very complex systems that we are all a part of it. But importantly, when it comes to risk mitigation, we need to understand what are these different governance systems, or maybe people involved in it, how are finances working in it. As a civic data lab, we importantly work with the different government to help them understand to make their procurement practices better. But the beginning is creating data ecosystem. So because a lot of you are students, so I think, and maybe perhaps a research student, so when I say that creating data ecosystem, you can see what are the current trajectories wherein even different academias and also the government has a strategic framework when it comes to state action plans within the climate and disasters. Within Civic Data Lab, we don't collect data. We help different agencies to open up their data sets, collaborate on different data use cases, and co-create data platforms. At the same time, also do the hand-holding and capacity building of different stakeholders to make better uses of the data sets. It can be as simple as like, you must have seen this is a regular situation where you attend any of, or when you visit any of the government offices. This is the rich data set, but it goes in silos. It doesn't interact with each other. Even as simple as that, if you book, like, maybe just like I'm bringing a very simple example, if you like, are doing some bookings on your Uber and Ola, even that data sets may not interact with each other. But like what I'm trying to bring it here is when it comes to specific government agencies, it's very important that different data sets interact. As what it also means in case of floods, like if there is a rainfall data available, which is a very rich data set, IMD, multiple organizations relies on IMD data, but it should also interact when we call it as like, aspects of vulnerability data sets or very critical data sets. So that sort of overlay and interaction doesn't happen, or even if it's happening, it is not happening with a growing trajectory of your digitization. So what we are primarily doing is like, assessing this risk level and the mitigation preparedness. This is what we mentioned in case of Odisha, but we are doing in multiple states of India. Importantly, as I mentioned, to prioritize their public procurement practices. What I was speaking continuously is something what it actually, in terms of infographic, a very simple explanation within adhering to the global guidelines, but also trickling down to how it is practiced by within the government agencies. So different data sets, you are quite aware of it, what is satellite and weather data, access to infrastructure, demographic losses and damages, and government fiscal response. Cumulatively, when we do certain sort of data modeling, it leads to a certain risk score. But what eventually it does is to create a comprehensive data ecosystem, break the silos wherein the data comes on a single data set, and so that timely access to the data sets and decision making is possible. We have done certain hand-holding. There are certain statistics and numbers when we have tested the solution. This is what presently the platform looks like. It will be inaugurated at the Assam Advantage 2.0 event in the upcoming event on 25th and 26th of February. But what we have done primarily is like, we have made the data interact. in a human form, if like two of you are climate scientists and you believe that your data your knowledge should interact and should help in better decision making, that's how it's the same data set the government, they have within the systems. And we have developed a certain sort of a mechanism which should sort of interact with each other, which looks like an overall flood risk. And this is again, I not need to mention it, but as a new NDRR framework, which is hazard, exposure, vulnerability, and government response. Primarily what it does, what you see the analytics here does a strategic mapping, risk mapping, but importantly, all the data sets, important data sets, which is in open access, or maybe the government is finding it very important to open up, they start interacting with each other. This becomes as a single point repository where instead of struggling to different sources, there is a single source wherein you can access to different data sets, which categorically become very important to identify and understand risk in that region. And these are different partnerships where we are scaling up globally. Recently, as I mentioned, we also had an opportunity to showcase our work at Paris AI Summit. But what I'm trying to bring it here is, as like in academics, we call it Global South. Like, you know, when we bring any shifts in terms of practices, and when it is heard in the larger, you know, domain, we actually become a champion in actually, you know, sort of developing any sort of, you know, frameworks. So the data sets, which I did not talk today in detail much, but these are the high value data sets, which is very easily and becoming accessible within different practitioners. And, you know, also in current times, decision making does not have to struggle between files and different sources. So this is as in Civic Data Lab, and I'm working as an associate initiative lead. We are like, you know, trying to work with the state disaster management authorities, and also different government agencies to, you know, sort of bring an empathetic framework wherein we make their work easier. To understand, you know, different aspects of mapping risk or maybe understanding risk, and also help them to, you know, shorten the time span for better decision making. So that's it from my end today. If anyone has a question, I can take it later. But thank you.
Thank you, ma'am. I think this is a very, very important topic. Data is all over, and all the data is actually lying in silos. There has been an initiative by the Government of India that all the data which are there from the mapping perspective and the attribute that should be brought in the common framework, and that is called NSDI, National Spatial Data Infrastructure. Now what has happened, there are around more than 20 organizations in this country which are actually preparing this kind of maps. And even after 25 years, 20 years, we could see that the organizations could not able to even provide the metadata. That means what data they are having, they don't have that catalog of that. So it's very important, at least for the sake of disaster, if state-wise, district-wise, this kind of data, if it is collected. Metadata is known, and there is a Bureau of Indian Standards wherein they have mentioned very categorically what kind of metadata format based on ISO, NOGC and INSPIRE. So there is a metadata standard by Bureau of Indian Standards where they tell all the data which is collected, if it is kept for searching, for discovery, if that can be brought in, that can add lot of value. So three aspects: scale of the data, format of the data, interoperability of the data sets, and the usages. So I think statewide, if you are doing, that will be a very good initiative, and I think that adds brings speed to the whole program. Thank you so much, ma'am. Our next speaker is Vimanyu Sharma. Vimanyu, if you have got present. He's manager in pre-sales at Esri India. Vimanyu has 8 years of experience in geospatial industries, MTech graduate in remote sensing and GIS from IRS Dehradun. His specialization in satellite image processing, business development, delivering innovative geospatial solutions tailored to client needs and technical capabilities. Over to you, Vimanyu. Yes. Ma'am has finished in 8 minutes. So I've taken her 2 minutes to further to make the whole thing happen. But anyway, please carry on.
Thanks, sir, for setting up the stage for me. So I'll be presenting what at ISRI India, what we offer the platform for GIS and remote sensing, right? So you must have heard all the previous speakers talking about data, everything about analysis, but what do we need a platform for that? Because GIS and remote sensing is the main thing. And at ISRI India, we have solutions, desktop, enterprise, for catering those requirements and make the results out of it in a very effective and beautiful manner. So just a brief about ISRI India. So you all must have heard about ArcGIS. So ArcGIS is by ISRI. So we are established in '96, headquartered at Noida. So we have offices at multiple locations across India, in Bangalore, in Mumbai, in Hyderabad, Kolkata. So we are a team of 500 ISRIites and growing for catering the requirements of various our clients. So we are working with major government organizations across India in you name any domain. So ISRI India is present there. They are using our solution from very back end, and they are utilizing it in a very effective manner. So first of all, I'll just brief about how ArcGIS is advancing. So there was a concept that ArcGIS was only restricted to desktop, right? But with the advancement, with the data coming in, so there is a lot of advancement in the data, in GIS data, in raster data, in IoT data, 3D data, mesh data, drone data, you name any data, the plethora of data is coming. But ArcGIS now has been advancing rapidly in parallel to the data that is coming. So ArcGIS now supports all of this data, right? So you can ingest the data within the ArcGIS platform, and you can do various analysis using various raster functions, spatial functions, network functions within the ArcGIS. So now, talking about advancement, ArcGIS is not only restricted to the desktop, right? So now we need a platform which is interoperable, right? So it should be available with the organization on an enterprise level. There should be a mechanism from where a person sitting in Delhi can share the data with a person who is sitting in Sikkim, right? So there should be a mechanism. So ArcGIS has now been made a comprehensive platform which includes your enterprise, your desktop, and other web applications through which you can share your services, you can share your data within your organization with your team members who are working parallelly with you on a single project, and you can create applications out of it for your better utilization in the real-time scenario. Now the first thing, as we are talking about, as ma'am also mentioned, is about the data, right? So within ArcGIS, we have a platform called ISRI Living Atlas. So what is Living Atlas? So Living Atlas is a platform where we have ingested data from multiple sources. So the data can be related to rasters. So we are working on Sentinel data, we are working on Landslides data. So within Living Atlas, we have tailored it in a fashion that you need not to download the data, so you can utilize the image services coming from Sentinel-2, Landsat 8, which will save your time, your system space, and make the competition fast. Coming on to next about the administrative boundary, right, which is a main concern once we are doing. So Living Atlas provides, India provides data up to village levels, starting with state, district, sub-district, and village, coming from an authenticated source like Survey of India. So we have partnered with multiple organizations across India, like Survey of India and GSI, where they are putting the data, and you can access the data from Living Atlas for your projects. Now, Living Atlas of the world, so it includes not only the data available within India. So you can consume data coming from major world sources like NASA. So you have data from soil moisture, which we have a soil moisture application which gives you a soil moisture across the world. We have a GeoGloFs layer which is coming from NASA. So all these data are ingested in Living Atlas of the world, and you can utilize it. Now the analysis capability. So I was talking about that ArcGIS is not only restricted to vector, right? So with the imagery platform, because we are talking about GLOF, right? So GLOF will require anyhow imagery, either a satellite imagery or a drone imagery. But getting a drone imagery is very tough for an individual who is working in a private organization or in any other thing. So we need to comply on the open source data that is available, right? And we need a platform which can ingest that, right? So we have a platform called ArcGIS Pro. So now I'll just give you a brief that GIS has now been transitioned to ArcGIS Pro, which is an advanced version of ArcGIS. The capabilities are more enhanced, more faster, and you can have more tools. There are more tools that are available in the domain. The capabilities are immense. So I'll just brief touch upon that, what all we can do with the mapping. So you can ingest the data. Mapping means like you utilize the data, drone data, aerial data, and now the analysis part. So the analysis is that now GeoAI is a buzzword that everyone is talking about, artificial intelligence, machine learning. So within ArcGIS platform, we have pre-trained models related to classification, change detection, flood, water body extraction using SAR data, so which are pre-trained over multiple data sets. You can ingest directly those training models, and even you can utilize or fine-tune the models basis your requirement. So it's an easy to use tool, so you need not to be a very expert coder or a very expert computer science student to do that. You can do within the ArcGIS Pro in a very simplified way and with a simplified workflow to get your end results. Now, the main thing is that we are doing analysis, but how to visualize it, right? The last thing is the visualization, because the stakeholders or the public who are the decision makers require a visualization platform. So ArcGIS is also a visualization platform where you can create your configurable dashboards, configurable applications. So we have apps called Experience Builder, which is a no-code platform which we say at ISRE India. So where you can create a application without writing a code. So it has various widgets, various templates. You can start using it. Even they are 2D and 3D capable. That's the beauty of ArcGIS that we have. Now these are some pre-trained GeoAI models that are included within ArcGIS. So I was talking about that you can have tree counting, you can have change detection, classification, water body extraction using SAR data, water body extraction on multispectral data, on drone data. So there are multiple models that you can explore that are available in the pre-trained GeoAI model. So ArcGIS is a content sharing platform. That's what's the main thing, that how to disseminate the information at this point of time, because everyone, we are working in silo in over here. So we need to share the information to various stakeholders. So this is one thing that I want to talk about, that ArcGIS Enterprise is a web-based platform used for sharing. So we have GIS professionals working on the desktop, we have knowledge workers, we have mobile workers who are capturing the data from the ground, but how to get this data and disseminate it. So ArcGIS Enterprise works in offline, online mode, and you can share the data with your stakeholders, with the people who are sitting in your labs from the ground in near real time, which will be visible on your dashboards, which will be visible on your Experience Builder applications. So these are some apps that I wanted to talk about. So you must be using model builders in ArcMap, right? So, but in ArcGIS Pro, the model builders has more enhanced. They have more capabilities. Now you can create very fast models because the system ArcGIS Pro has been made fast. It's operating on 64-bit system now, so it's capable of doing the processing fast, making the images catalog very easily, and you can work on 2D and 3D data. Also, you can have your configurable mobile applications. So we have applications like Survey 123, Field Maps, which are config mobile applications. So you can create your own survey forms depending on your requirement that you're giving to the field workers. They are just a drop-down Excel sheets. You can ingest that, and they are directly interlinked to your applications that you're making on the web. I'll just brief. So this is one glimpse that I wanted to show, that within ArcGIS Pro we have various tools related to simulation also. So on this side you can see it's just a visualization that we did for South Lanka Lake in Sikkim. So we created a simulation model. So it's I won't say it's 100% accurate, but yes, these gives a tool to the users to visualize that if in case any disaster happens, the scenario will be like this. So it gives you a pre-preparedness kind of thing. So you can create your own simulation models. Now here on the bottom, on the right side, you can see this is an Experience Builder application to edit the lakes that you have identified for using NDWI indices or NDSI indices. You can create your applications like that. And finally, to disseminate the information, you can create your own dashboards. You can create a year-on-year dashboard to see how the areas have changed for the lake, whether the area has increased or decreased in a real time, how the lake boundary has changed, whether there is a breach, and also if you are utilizing SAR data, you can perform your interferometry analysis now within ArcGIS Pro. So that's all about the capabilities of ArcGIS Pro. So there are many other capabilities which you can explore by visiting ISRI India's website. You can have a look at ArcGIS Pro Desktop, ArcGIS Enterprise, and the extensions that are available with the ISRI platform. So thank you. That's it from my side.
Yeah, thank you, Vimanyu. I think this platform which Vimanyu has explained, this is, I think, the first commercial GIS which started in 1969 at Esri, Redlands, US. Most widely used commercial GIS based on the open standards. So I think today if we say the most number of users who are using professionally is the ArcGIS user. One aspect probably what he has not directly highlighted is that now a lot of Indian data is also now being incorporated with IndiGIS, right?
Yes.
So that is one added value on top of the Indian users who can straight away not only get the foreign data sets but also the which he has highlighted in some form or the other like Survey of India and other sources. Our next speaker, as per this agenda, is Harinarayan, but I would like to first give this opportunity to Gaurav Vasudhani. Okay, he will speak after this. So Gaurav Vasudhani is Head of Business Growth and Strategy at Eagle, Tech Eagle Innovations, and he is specialized in drone-based delivery solutions with expertise in business expansion, digital transformation and technology. He has played a pivotal role in advancing drone logistics strategic initiatives in India, right? Gaurav,
yes.
Yes.
One moment. So, a warm good evening to all the guests here and co-panelists, and thank you for that lovely introduction. As the presentation is just loading, 1 minute. So, a lot of conversation today has been around, in the recent ones have been around data collection. I'll be talking about the drones and how drones are helping in the disaster from the logistics perspective and from the relief and image and data capturing perspective. Yeah. The presentation is taking a time because it's a big presentation, so heavy actually, not big. Right, so at Tech Eagle, we are creating advanced logistic network of drones, and our long-term vision is to create an on-demand drone logistic airline. This is our brief journey. We are pioneers and leaders in drone-based logistics in India. We were founded back in 2015 in IIT Kanpur. Then we went on to conduct world's first tea delivery, partnered with Zomato back in 2019 for food delivery trials also. Then in 2020, we were the first company to buy the DGCA to be invited for beyond visual line of sight delivery trials, which were very successfully done. And henceforth, we have partnered with multiple state governments, starting with the government of Meghalaya, also working with Uttarakhand, Himachal Pradesh, where we are delivering medicines, blood, vaccines to very remote locations on regular basis. Recently, we were also impaneled by a couple of All India Institute of Medical Sciences like AIIMS Rishikesh, AIIMS Guwahati, PGI Chandigarh, AIIMS Bilaspur also as well, where we are doing deliveries to very remote locations with the help of drones. Yeah, so this is our team. Mr. Vikram Singh is the founder and CEO, is an IIT Kanpur alumni. Mr. Anshu Abhishek has got over 8 years of experience. He is co-founder and COO. I head the business growth and strategy at TechEagle. I have 17 years of experience. I am an executive MBA from IIM Bangalore. And it's a young startup comprising of aeronautical engineers. So we are manufacturers of the drones. So we have in-house team of mechanical and electronics engineers in the manufacturing team. We have on top of this, we also built a software, which is a ground control station. So if we have multiple drones, we can track the entire fleet of drones on a single screen. So we have a team of software engineers as well, and we provide drone as a service as well. So we have DGC approved pilots as well. These have been two different instances when we had an opportunity to meet the Honorable Prime Minister. On the left hand side, the drone festival in May 22, then again in June 22 at a groundbreaking ceremony in Lucknow. And both the instances we had the opportunity to share what we have already achieved in the drone ecosystem and how we are changing this segment. Briefly talking about the projects. So first project that was taken up by the government of India was the Telangana Medicines from the Sky initiative, where drones were used to deliver vaccines to very remote locations. This was first in Asia where drone was used to deliver vaccine for beyond visual line of sight. Beyond visual line of sight is beyond 1 kilometer if there is a flight. So it is considered to be a beyond visual line of sight. And in this project, we cumulatively flew 225 kilometers. And the best part was we maintained cold chain of 2 to 8 degrees during these flights. Then on the similar lines, the government of Meghalaya along with NHM invited us to conduct some trials for them. And the use case that they wanted was that by road it takes about 4 hours. How much can you reduce with the help of drones? And we were able to bring it to 25 minutes. So we were 10 times faster than the ground logistics. Similarly, in Nagaland, which was the most technically challenging project, we flew about 40 kilometers with medicines delivering from point A to point B. And the technically most challenging aspect was we crossed a mountain range which was 1.5 kilometer high. So that was, a lot of international players were also invited. We could successfully demonstrate our capability there. Similarly, in Himachal, in sub-zero temperatures, -5 degrees, we delivered medicines to very remote locations there, and again, very windy conditions as well. Again, this was pan-India. We have done projects. So Kutch was another section where you can have very high winds. So we conducted a trial for India Post, delivering the posts to very remote location, and this was the day when we conducted this. There was a wind speed of about 31 kilometers, and we successfully demonstrated. So as on date, by any vendor in India, this is the longest flight of 46 kilometers, autonomous. So nobody was flying the drone. The drone was automatically from point A to point B conducted these flights. Similarly, for the Animal Husbandry Department in Arunachal Pradesh, we delivered vaccines for the Animal Husbandry Department. And by road it was taking 2.5 hours, but by drone we were able to bring it down to 20 minutes, so 92% reduction, and that's a TAT reduction. That's what. Our most pivotal project is Meghalaya, where we created Asia's first drone delivery hub. So there is a central hub, and from there about 25 PHCs and CHCs we are delivering medicines and vaccines on regular basis. This is something which is very unique. And it's the first in Asia where on active basis daily active flights are being done. Recently we partnered with AIIMS Rishikesh and AIIMS, other AIIMS as well. This is a short video which will give you a sense of how drone as a service works, drone as a delivery service works. This project was also brought comments from the Honorable Prime Minister. Similarly, AIIMS Jodhpur, AIIMS Bilaspur, and other AIIMS we are already working. So yeah, these are some of the partners with whom we are actively participating. This is our flagship product, Vertiplane X3. This is capable of carrying 3 to 5 kgs of payload. It is also India's fastest drone. This can fly up to a maximum speed of 120 kilometers per hour, and the range is about 80 to 100 kilometers. So it's a fully electric drone, which can operate at maximum height of 4,500 meters above mean sea level, and temperature ranges of minus 15 to 60 degrees. So yeah, this is our flagship product. The previous generation product, which we were also working with earlier, was 8 kg, can carry 8 kgs of payload, go up to a range of 20 kilometers. Other parameters remain. So effectively, whenever disaster happens, this is something which is can be very, very critical and crucial to immediately deploy services, emergency response. In fact, we have provided some of these drones to a couple of state governments also for the disaster departments. Just to talk about some of the features of the Vertiplane, it's a vertical takeoff and landing, so 20 meter open clear space is provided. We can do vertical takeoff and landing. Just to get 100 kilometers range and 120 kilometers per hour maximum speed as into perspective, Delhi airport to Nimrana is about 100 kilometers. We can conduct these flights in 50 kilometers. Likewise, Guwahati, Shillong, Mandi, Manali, Dehradun, Uttarkashi, which are 60-64 kilometers. The flights can be done in 30-32 minutes. Payloads in terms of blood samples, we are working with the healthcare, so 150 samples of blood can be transported. Medicines, if transported, we can move about 5,000 units of medicines. And then we also partnered with some e-commerce companies, so 12 smartphones. So that's the space, just to give you a perspective of what the space is there. Cold chain can be maintained, so 2 to 8 degrees cold chain, live temperature and data logging is enabled. These are the various mechanisms in which we can release the payload from the drone. So in case it's a disaster, we can have a winch release, so difficult to land or disaster hit areas, this could be one solution. Other solutions can be parachute or auto release as well. The default setting is the manual takeout. Fast and smart charging, it's a fully electric drone, so we can swap the battery in less than a minute and we are good to, so very low downtime. We are the manufacturers of the drone, so we can customize it according to the requirements, but over the years we have made it modular, and it's 100% composite. Again, minus 15 to 60 degrees, snow, desert, coastal hills, 4,500 above mean sea level. So all weather, all terrain capability, that's what we got. Wind resistance of 45 kilometers per hour. Another great thing about our drone is that all flights are autonomous in nature, which effectively means we do not require our pilot to fly these drones. These can be just like a Google map, we will provide the takeoff and landing location, and the flight will be conducted autonomously. So that gives us an edge in terms of disaster also. If night operations are to be carried out, it can be very, very useful and handy. We've got redundancy on propulsion, redundancy on communication, so we generally operate on 4G, 5G network, but in case there is a challenge, we can switch over to the satellite communications as well. We have made our drones very fail-safe and reliable as well, so battery fail-safe, wind fail-safe, detect and obstacle avoidance is also enabled in the drones. Then we have parachute also in case multiple failures happen, so a parachute can be deployed in order to bring the drone safely on the ground along with the parcels. This is another key feature that TechEagle provides is the cloud-based ground control station. So the entire fleet of drones can be tracked on a single device, be it your desktop or a mobile. You can live track the flight, each flight on your smart device. Very proud slide from TechEagle's perspective is that this is made in India, so it's easy to service, can be customized. We are designing our drones in India, developing drones in India, manufacturing and testing drones in India. Another key features from TechEagle's perspective is that the drones we have manufactured, we have done over 10,000 kilometers of test flight, and we have done over 10,000 kilometers of delivery flight, and this number is going up daily because we are daily flying for AIIMS Rishikesh and AIIMS Bilaspur and AIIMS Guwahati. So yeah, so we have drones are rigorously tested, and we have the most experienced operations team in India. This is our current roadmap. So just to give you a perspective, this is how the long-term vision of the company is on the drones and how we will be changing. And going in the long range, we'll be going to 200 kgs, going about 500, taking 500 kilometers, taking 200 kgs, and this is where our long-term vision of creating on-demand drone logistic airline will become a reality, connecting all the pan-India. Yeah, that's it from my side. Thank you.
Yeah, thanks, Gaurav. I think post-disaster scenario, I think one of the principal secretary of the state whom I met, who was specifically asked if you know somebody who is reliable. So I think we can talk after this session.
Looking forward.
Now I invite Dr. Harinarayan Tiwari. He needs no introduction, so Hari, you can just carry on.
Thank you very much. I will continue with what is mentioned about the uses of drones. So I will just come into that, what the data we are collecting, or what the data we are collecting through that remote sensing, either through the drones or satellites. So what are the general utilizations for, like lots of students are here, so they can learn that there is multiple opportunities in the industries and they can utilize for their future. So remote sensing techniques, all of you are aware about that, and its uses is, you can say, unlimited. In every aspect, either it is a disaster or non-disastrous item, you can understand the technical features, you can understand, you can enhance the social lives using the remote sensing. So I'm just straightforward coming to the applications, so including from a defense, agriculture, geoscience, development, constructions, everywhere it now it is in use. So only thing that you have to understand that from where you are getting fit into that. That means if you are from the background of geoscience, so you are fitting into that part. If you are from the defense or something like that, so that is also fitting into that. And you have to learn some kind of analytical tools also, as mentioned by like Esri people, that they are developing multiple tools to utilize those kind of data. So coming from the structural health monitoring, suppose even at the time of disaster, you would like to know that what are the scale of disaster, so that you can easily measure from the pre and post disasters. That means what are the damages and how you have to focus on that, your preparedness or your mitigation plan. So in urbanization and transportation, we are looking into that. That means if you are just back to the 15-20 years, so it's not easy to go anywhere, you have to ask for the address, but now there is a Google Maps, so, or other maps are also, so because that is only possible because we are also providing a good data set using our mobiles as a system to that particular system, and now the mechanism has fixed and you are getting a good information out of that. So apart from that transportation, we are also looking for a different kind of disasters, floods. So in the future, as the infrastructure develops, like the systems of drones and other things, surveillance will increase. So from the services and analytics, we are getting a good information which will be helpful for the disaster mitigations and preparedness. In the natural resource management, like in a forestry and everything, we are utilizing those GIS items and remote sensing data, what we are taking through the satellite imagery or other process. In agriculture, like we are into the soil sensing, we are having the soil moisture data from the NASA and other. But the thing is that you have to do the analytics and you have idea about the tools. That means from using what kind of tools you have to analyze for the agriculture purpose. Now there is a kind of the tools which is also available for the financial analysis of that agriculture. Suppose if any bank is going to provide the loan for the farmers, so there is a financial mechanism is also intruding through the remote sensing and analytics. So you can say it's a premium based system, whether the risk is high. So that analytics, the GIS and all those remote sensing tools is having a use. And why it is having a use of like in future, why we are talking lots about the remote sensings. Because the thing is that where suppose as he mentioned that if you have to provide medicines at the time of disaster, so physically maybe you are not able to go, because I'm just mentioning that last T-Star disaster where up to 3 days there is no access to that particular area up to the 3 days, even to the top officials. So that is the problems when the disaster is happening. So that's why the remote sensing or any kind of this kind of services plays a role. And apart from that, you can also analyze the past data also, because if suppose from the satellite imageries, you are analyzing since 1970, maybe you are not born at that time. So, but you are analyzing when you are creating some kind of tools or analytics for that. So these are some kind of like soil moistures and other things which is already available through the NASA. If you are doing some construction sites where you have to avoid some kind of construction hazards and other things, so in that also that kind of analysis or tools can be useful. In a traffic monitoring, in military surveillance, you have given, suppose if you are having some kind of war situation where the remote sensing can be used. So these are the general uses which can, suppose if you are expert in one particular items, so you are fitting into the industry, because there are certain items which is we are talking about that what are the quality of students which is coming in future. So if you are able to handle those kind of tools or analytics, so you are able to fit into the industry. So that is the one point. If you are going for a floodplain delineation, so that is also available through the different kind of image analytics that you can do. You can analyze, suppose if you are trying to make any flood-proof area, because flood is also kind of disaster which is happening some kind of plains every years. So that can be averted if you are trying to plan using the floodplain delineation where the river is moving, because river mobilization, if you have heard about the river Kosi in Bihar. So the river Kosi is moving around more than 108 kilometers in their floodplain. So that is one of the major issue where the people don't know actually from where the flood is coming. So in the societal aspects, you can do this kind of plannings and analysis using the remote sensing and GIS, agricultural monitoring. So that is also one of the aspects of remote sensing, and lots of startups has come which is coming through that agricultural monitoring part, because it is you can say one of the highest contributor of the GDP of India. So obviously it is very much useful, and in future it will come. In fact, when we are talking about the rainfall related disasters, so that is also one kind of development using the GPM, like Global Precipitation Mission, where we are collecting advanced data, you can say a real-time data, which we can measure and analysis for the any kind of disaster which can occur. So this kind of happening, and just one point I would like to highlight through this particular presentation is that from the remote sensing, the data which we are lagging generally, and we are saying that we are not having a data. So that part can be sorted out maybe in 5 to 10 years when we are getting a lots of data. Only the thing is that analytics and interpretation you have to know. So that is the important part. So I will not go in the details. So these are some kind of items what I have mentioned here. The presentation is also available that any analytics what you can think from the remote sensing, that is possible nowadays, because remote sensing is not only that we are taking what we are taking from a satellite, because as name suggests that what the data you have taken without touching it. So as natural, you can say the eye is the first remote sensing equipment which we can see lots of things. So apart from that, we are having artificial development like satellites, drones are there. So eye is the first kind of remote sensing equipment. So that can be utilized, and it can be huge opportunities for the upcoming future. So thank you very much. Thank you.
Thanks, Dr. Tiwari. So couple of slides I just wanted to show just for the coherence of the session. If you can just put the slide here. Can I remove this?
Yes, sure.
Which one? This one or this one? Sorry, I mistook it by him. इसी पे रहने देना, कॉपी करने की जरूरत नहीं है. Yeah. So basically, if you see the theme of the conference, which is GeoRisk. So risk, by definition, it is actually the probability of loss in a community that happens because of this interaction of this hazard, vulnerability, exposure, whatever you have heard. So we need to assess beforehand what is the loss, and one size will not fit all. You do have the satellite, you have got the aircrafts, you have got the mobile mapping vans, you have got the sensors. You also heard about Dr. Tiwari talking about eye as a sensor. So everything put together. So very quickly I'll put across my presentation. We are a mapping company, we deal with 3D. By and large, we do a lot of work on the 3D part. We are the pioneers of LiDAR in India, and we do have prime 2 products. One is the Street Vision and another is the Oyster. And we have been mapping the world for almost last 25 years. India, we are very sincerely, we have been working for last 10 years now. So there is a policy by the Government of India, Department of Science and Technology, that what is that Indian companies can do and what is that foreign companies can do with respect to the mapping of this land. And it has been very categorically mentioned that beyond a certain resolution, no foreign companies can come and map in this country. And that is how we have taken one of the very flagship program of the Government of India, which is called Digital Twin. For that, we have signed an MoU with Survey of India. So one of the aspects, before I come to the subject of the digital twin, is that we are all familiar with these maps, like 2D maps. It is all about point, lines, polygons, text, boundary, annotations, all that is there. But imagine Taj incident which has happened in Mumbai, where the terrorists, they have attacked, and we give these NSG commandos with these 2D maps. They go to the field and then actually they find this is the scenario. So there is no live relationship between what is actually provided to you in a hard copy map or in a digital map in the 2D, and when you go to the field, you actually see the whole environment has changed. So there is a need for now to get into 3D. Earlier there were a lot of technological compulsions, limitations, but now we have overcome all of that. So as a company, we also felt that it is very important we create these 3D models for various cities of the country proactively on our own. So this is the assembly which we call Genesis Constellation. We do have around 4 manned aircraft. We also take and leverages the satellite data. We do have dozens of drones. We do have, if you see this kind of mobile mapping vans, Mahindra Bolero and Mahindra Scorpio, we have got around 125 of those. Those of you who are familiar with Google Street View, Google Street View is that 360-degree panoramic view of these streets of India. So we provide this data to Google. The data belongs to Genesis, and we have licensed this data to Google. Similarly, those of you who have been working with Apple Maps, with the iPhone, so we provide and we create those Apple Maps. And similarly, for a lot of automotive companies worldwide, we create this ADAS scenario for HD maps. So different tools and technologies we use with our 2,000 people. So digital twin, this is very, very interesting aspect, because the real world, whatever is happening, if you can replicate in the digital world, that means you see there is a wind flowing, you can't see the wind, but actually you can represent the simulation, you can create the animation with the speed and the direction with an arrow, that this is how the wind is flowing. So actually in the digital world, you see more than what is actually you can perceive in the real world. And that's what is this one of the aspects, there are so many of it. So virtually, if you can create very accurate digital models and then simulate the real world happenings, that is what we are actually trying to make it happen. So there is a maturity model. So we start with the physical models like 3D of the buildings, but that is no information. So we collect the data. Like the previous speakers also told, this kind of data sets, whatever you are collecting, if that put on top of these maps and models, that gives a life. You can query the data sets like what S3 people have also told. You can query that data. And you can come out with the SQL query, the various kind of results. But that is not all. That is normal GIS, 3D GIS. The actual crux is about real-time feedback. That means how the sensors are operating. If there is a movement which is happening, and if I do have a sensor, if the temperature is there, if there is a city of Delhi, and every meter is an energy meter which I can connect smartly, I can paint the whole city in red, yellow, and green, telling that who is consuming more of this energy, and so on and so forth. So I'll practically give you 2-3 examples. So interactive twin is something which deals with the IoT devices, Internet of Things, and then we automate it. But the whole part which we are looking for partners, as of today we do have 2 partners. Both of them are from the foreign countries. One from France, one from US. It's all about the predictive models. The whole objective, you do everything, but how can you predict what is going to? So science of, what if scenarios if you have to create. So as of today, we do have this computer fluid dynamics, which I'll perhaps show you a couple of examples. But from the landslide perspective, from the flooding perspective, 2 very important aspects is, one is the terrain, another is the rainfall. In the morning also we heard that a lot of rainfall induced landslides are actually happening. So this is not actually a picture which has been taken in the ground. This is a LiDAR data which has been simulated, and this is what you can see the complexity. Centimeter level data accuracy which is there, which can actually showcase the cross-sectional profile. So this kind of aircrafts are there, you can create this kind of contours. This is the LiDAR data sets, and this is now the informative model. All the data sets pertaining to the various landslides. This is just an example. You can create a database and you create the informative model of the landslides. All kind of sensors which are there, which is the tilt sensor, rain gauge sensor, you have got the radio links, everything can be integrated on top of that. One of the aspects of the sensors we found that while this Joshimat is there, we have worked with INSAR data, interferometry synthetic aperture radar. And then we could able to sense that this thing is not happening now, it has been happening for last 5 years. We could have all those evidences. This is one of the aspects that prediction is also there. Different kind of models, but it has to be tested, tried based on the environmental conditions. One of the other aspects we have also found is the susceptibility map along the road section. Joshimat also, immediately after the incident, we flew a few drones, we could able to find the cracks. We shared with the state government that what is the crack management, how much is the damage that has happened. And then various kind of on the fly, if you take the LiDAR, mobile LiDAR data, you can actually find what is the height, what kind of rock mass, what kind of joints, what are the different aspects which is the causative factor. This is all about all along the changes of the road that we carry out. And one of the aspects which one of our Japanese counterpart, they have been supporting us in this endeavor, is about the lake which has been talked. Again, it is the Sentinel-1 INSAR data. Millimeter level deflections, because all in the Himalayas, all in the northeast remote area, you cannot put sensors. If you get a feeling that, okay, there is a movement, somebody has to go test it out, whether it is actually happening or it is a false alarm. And then once this kind of things are there, so this is government of Sikkim, they are very excited about utilizing this kind of technology. We have been talking about the wind simulation, that this is how you simulate the wind. What you see is the static, but actually it is a dynamic thing at what speed in. So at least somebody forecast IMD that, okay, this is the cyclone which is expected. Now based on the type of the buildings and the rooftops, whether it is a tin, whether it is a thing, whether it is a concrete, what is the probable damage that can happen and who are the people who are likely to get affected. Similarly, for the fire incident, like we are working on the width of the road, which is currently not there by any of the mapping agencies. That depends upon which road, what kind of fire brigade and what kind of vehicles can actually ply. So in summary, basically this National Geospatial Policy mandates that if you are an Indian company, you are free to survey every inch of the land, minus some of the areas which has been demarcated by Ministry of Defense. Other than that, everybody is free to use. This fine-grained data can be shared with everybody. And digital twin content program, that is what we are carrying out with multiple states. And we do have this kind of platforms which sits on top of Esri, which sits on top of open source environment, and then we can readily plug and play and support these initiatives. Thank you so much. So with this, I see at least 2 or 3 questions if it is there for the panelist. That would be good. Then we can at least logically end the session. Any type of queries? Yes, sir. You may please identify yourself and then you can pose the question.
Sensei Raj, founder of India 2032 and a class management expert, contributor to the forming of the NIUA country. You mentioned Sikkim. I wish I had some of you people with me in Sikkim. I'm the person who has done the initial damage assessment single-handedly with whatever. Okay, thank you. Do you want me to start or I can just
Yeah, you can start.
Sensei Raj, founder of Vision India 2032 and also Global Changemakers Network. I do strategic interventions and also damage assessment expert, so-called. Let me put that caveat. The last one was in Sikkim with the glacial cloudburst, which devastated the entire state, and also in the last Wayanad, where I've also done the damage assessment and search and rescue operations as well. Now, my question is very specific. In fact, what you suggested last, I'll go in that particular order. If I had you before, I think we could have done a lot more in the initial stages itself, like in the displacement of the land and the movement of the valley itself, and then how in the past 2 or 3 times that we have bungled so badly in reconstruction of the previous the floods which have happened. So now I myself have promised personally to about 3,000 people to rebuild their houses, and I haven't seen any movement or uptick in that aspect. Being the state or any of the agencies, their idea was to build temporary shelters. But then the load calculations upon the valleys, how we could map them entirely, integrated, connect the dots, those things are still needed. But what you have done, in fact, I would like to include you in my delegations where I go to different countries as well. But my question stands is that why aren't we able to connect the dots, work across verticals, like the drones, for instance. I particularly am connected with companies who manufacture drones. I consult in this area. Maybe we could increase the payloads from 8 kilos to possibly 100 kilos. We have the technology, but do we have the openness, the broad-mindedness to work together to take a country to the next level? That's one. And then if anybody has a technology to calculate the load bearing on each valleys to build and also for the initially, like as you mentioned, what fire, because I'm an advanced firefighter myself, and how we could move the initial first responders and also the overall plan to search and rescue and then to follow on rebuilding. I think I'll stop there.
Yeah.
Thank you.
So very nice suggestions and inputs and very valid. Let me tell you, Government of India, Department of Telecommunication, they've initiated a program called Sangam. This Sangam program is all about bringing multiple departments, stakeholders, research organizations, which is called Digital Twin Sangam. That means it's a confluence of technologies, policy holders. And we had 3 different workshops in 3 different cities where companies like Google, companies like Meta, plenty of startups, triple IITs, IITs, they all came. I think you were also there. So the objective is that in disaster scenarios, speed is of essence, time is of essence. And that's what it is very important, that what is happening in the real time or near real time, if that can be supported, that is the thing. And specifically for fire also, one of the aspects which has been dealt with at large is the role of telco service providers of this country. All of us are actually using mobile phones. These mobile phones are actually the live sensors. Right from you say good morning to somebody in the WhatsApp till that good night, your entire record is being there with somebody. Now, by virtue of law, only the law enforcement agencies actually can take that. But now, a policy is being made that without identification of the single account holder or the SIM holder, if there is the anonymization of the data which can be aggregated, a fire scenario, like we have got a fire scenario, how many people are there stuck in 4th floor, 7th floor, 9th floor, because there is a Z value which is also playing a role. How many people are crowded in the gate, that cluster? What is the traffic? So we need not have to depend purely on Google Analytics. There are n number of, so the solution is there. It is just a modality, the business model which is now getting implemented. So that will, we can leapfrog the whole aspect of, because technology prototype has been demonstrated. So it is up to the policymakers to now create the policy and see to that how it can be done. Post-disaster scenario, yes, multiple places, this drone logistics, and I could see that this is now a real thing. It's not no longer a pilot, subject to the conditions of, typically, as you know, 90% of these disasters are hydrometeorological in origin. That means whenever this kind of things, there will be rain, there will be very strong wind. So at a peacetime, this will definitely act a very good thing. But when there is a windy affair, when there is a rainfall, definitely it will hinder. So each and everything has got its pros and cons, but that is how. But the most important part is preparedness, which Colonel Srivastava again and again tell about the early warning system and the preparedness of the first responders. These are the only two things which any day, technology will come much later, but these two things we need to see to that, so that at least technology and the people, when they go hand in hand, that is how we can react swiftly. Any other comments from any other, ma'am?
I think the first question, when you mentioned that, the part that you mentioned that, why we work in silos in terms of, though we have rich information, rich technologies. I think like last 12 to 13 years of working very closely in different disasters and working very closely with the people, but importantly with the decision makers, which I also mentioned as a part of the presentation. As an empathetic approach, where exactly can we identify the pain points? Sometimes what I've realized in this many years of working closely, it's not what amount of richness one brings in terms of whether it's technology or data sets, but how can we handhold in terms of equipped decision making. It's very simple example, when you go to any of the directly impacted regions, the first responder from the government agencies, like at the most bottom level, are the field officers, who are actually the champions. For example, in case of Assam, they are the Gram Budhas. They are the champions who can actually help you understand even maybe your data sets which are captured digitally may not resonate with what the Gram Budhas are doing, but that becomes a very rich information, and that becomes very imperative in terms of decision making, because that is compiled as an entire report. For example, in case of disasters, all the SDRF and NDRF funding are allocated based on what the state reports are generated. Now, the state report actually relies on what these local champions are building the data sets. If you see, the state report does not identify any of the corporates or any of the private agency unless it is entitled or empaneled. No matter how much information you would bring in. So the point that I'm trying to make is, when we are as a part of the system, understanding the pain points, diagnosing it, and working very closely as hand-holding can actually enhance these entire aspects. That's what I can actually respond to the first question.
Yeah, thank you.
Thank you
we can
for that.
discuss it after this program. Any other query? Any other questions? Thank you so much. So with this, we'll end this session. Yeah?
I have a small suggestion.
Yeah, sir, please.
It was so enthralling going through each presentation. So the crux is we have so much, knowledge, systems available. We must create a platform where what Rakhi was saying, we should be doing each other's hand holding and gap, filling up the gap. So that is what is the requirement, because somehow what she said, when you go to a decision maker or any institution, you know, we all are common people who are working with a disaster reduction system or CCA. So we must have a database where who is doing what, and we should be accessible. We are at Delhi, Masand Kunj, we offer our services, our organization is there. You want to hold a workshop, you want to do something, why to come to a, you know, very expensive, we have the hall with 150 capacity, we are in a prominent place. So they are necessary hand-holding. We are working with a state government. So whatever is the state requirement can be shared in our common group and can be undertaken by each other, you know. So everybody's expertise can be facilitated.
And a point very well taken. And I think I will ask Rakesh to at least take some lead to create this platform, right?
In fact, I curate the disaster management group, not only in India but also globally.
No, I think we can get a stakeholder thing. Very important.
Precisely, that's exactly. See, in fact, when we wrote, when I contributed to it, this, what you said just now is part of it. This I'm talking about in, what, 2005, although I left the country. It was 2005 to 2008, then later on NIUA came into picture. But that's not how we are operating today. I'm sure you agree with me. What we see in reality in the forefront is entirely different. Because when the Uttarkashi tunnel incident was happening, we were briefing the entire regiment of NIUA in their headquarters. And we said, give us 8 hours. We'll take them out completely. But that was how it was done. See, there's a lot of things which are not in alignment.
And the points very well taken. Thank you so much for patiently hearing. This is the last session. We'll no longer hold you. Thank you so much. Yeah, any other formalities?
I would like to thank all the respected speakers of the session for their valuable and innovative insights on tools and technologies for risk assessments. Now I would like to call upon Mr. Vishwajit Sahu, Group Director, ResQore, CDPRR and Playzone Private Limited, to hand over the mementos and deliver a final note of thanks. Dr. Anirudh Roy, Chief Technology Officer at Genesis International. Ms. Rakhi Kashyap, Associate Initiative Lead, Disaster Risk Reduction and Climate Change, Civic Data Lab. Shri Vimanyu Sharma, Manager Pre-Sales at ISRI India. Dr. Harinarayan Tiwari, Founder, FloodCon Private Limited. Mr. Gaurav, Business Growth and Strategy, Tech Eagle Innovations Private Limited. I request all of you to stand up for a group picture.
Rakesh. So the customary vote of thanks. On behalf of the organizing team, I extend my heartfelt gratitude to each of you for your invaluable contributions to GeoRisk 2025, Conference on GLOFs, Earthquakes, and Landslides. Your insights, expertise, and active participation have been instrumental in making this event a great success. A special note of appreciation to our partners for their unwavering support. Our co-organizer, National Institute of Urban Affairs, strategic partner, Hansraj College, University of Delhi, host partner, the Center for Disaster Preparedness, Recovery and Research, media partner, Medalytics by Playzone Media Management Private Limited. Our sincere thank you note to Colonel Sanjay Srivastava, founder and chairman, Climate Resilient Observing System Promotion Council, CROPC, Dr. Anirudh Roy, Chief Technology Officer, CTO, Genesis International, Ms. Rakshi Kashyap, Associate Initiative Lead, Disaster Risk Reduction and Climate Change, Civic Data Lab, Sri Bhimanyu Sharma, Manager Pre-Sales, Esri India, Dr. Harinarayan Tiwari, Founder, Floatcon and PNDT Solutions, Sri Gaurav Asaudani, Head Business Growth Strategy, Tech Eagle Innovations Private Limited. I also extend my deep appreciation for the in-house organizing teams of Medalytics and ResQore for their efforts in curating and bringing the GeoRisk 2025 conference to life. Thank you all for being a part of this conference. We look forward to future collaborations in advancing the GeoRisk mission. Now let's continue. And now also give a all round of support to our volunteers from Hansraj College and other institutions. And now I would like to invite you all for networking tea for the Chai Pe Charcha so that we can continue our discussion further. Thank you.
Actually launch होने वाला है honorable PM sir के
आपका IHC
presentation
presentation था
हाँ तो before that I can't leave it. Sure sir, I'll just share my card. Coming in a second.
Delete?
हाँ shift delete कर देना.
हो गया क्या चीज़?
नहीं recycle में नहीं shift delete.
जी हाँ मैं कर लेता हूँ.
राकेश सर मैं अपना presentation separately देने वाले हैं because this is actually going to be launched अभी honorable PM sir का launch होगा. So before that I can't share it in a public domain. So there are a couple of slides which I'll delete and I'll mail you the separate.
ये कल भी खो गया था ना सर, इसके साथ आता है कल हो गया ना.